and welcome back. This morning it was discovered that there was a problem with Stockfish playing the variant of chess called losing chess or loser's chess, or it goes by other names too. The notion of this game is it's just like anti chess, except the king has royal treatment, so you're not allowed to give away your king, nor are you allowed to promote your pieces to extra kings. And the objective is to lose all of your pieces, um, except your king, of course, which cannot be lost. This leads to quite a few interesting situations where a player has just a pawn remaining, and that remaining pawn is eventually forced to capture everything of the opposing army. Um, so the reason that this game works at all is because captures are compulsory, despite the fact that you're trying to give away your pieces. If you can ever make a capture, you have to make a capture. And so consequently, the move generation for that particular variant of the game is pretty tricky. Not gonna lie. Um, so what we got to do here is figure out how are we gonna fix this. Now, I will say before the stream, I did spend some time coding and preparing my own solution for this, as did another developer. And now comes the interesting, somewhat political part of this, that we have to reconcile our approaches, set aside our differences, and come up with an approach that we're all satisfied with. Um, so, the obvious thing is to say, hey, look, we found an example game where it's broken. Let's just fix the one thing that's broken, not worry about anything else, because we're not aware of anything else being broken. And just patch that one little thing, and then hopefully later on we won't be stung by something like this again. I mean, this is the best we know how to do, right? Another philosophy would be revisit everything from the ground up, um, and try to figure out what exactly went wrong, um, and just try to simplify and refactor the code to the extent possible. And I got a bit carried away with that, I admit, um, because at some point it became clear that I wasn't able to just refactor the code. I had to basically rewrite the code, um, in order to address all the potential issues that came up, just because there's so many things to worry about. So now we got two different patches for this issue. Um, One by the original developer, Fabian Fichter, excellent developer, excellent tester, very good at organizing things. Perhaps not so familiar with this project as I am, but overall an excellent person to work with. Um, then there's my patch. Um, and so, my patch, I guess it wouldn't hurt for me to go into the differences here. So, let's see. That's his fix. And then there's my fix. Wait. Is that self-referential? Did I click on the wrong thing? Oh, no. No, this is a pull request containing his code changes. And we discussed this a bit and came to the conclusion, yeah, if there's an elegant way to rewrite the code, by all means, let's rewrite it. But if there's not, let's just do the simple thing and fix the simple thing. And um, so, yeah, the simple thing is just fix the one line of code, which addresses this particular use case. And I have not shown you that use case yet. So allow me to show it to you. I took this block of moves and imported it into Lichess. Now you'll say, Dan, Lichess doesn't support... Oh, I have to log in. 1 second. You're saying, Dan, Lichess does not support loser's chess. How did you manage to import this game? Well, like I said, The rules of loser's chess are such that the king has royal treatment and cannot be captured, right? So the objective might be different. The objective might be to lose your pieces, but the rules are all the same. So I was able to import this game. So in this position, Stockfish is like, well, I have to get out of check. So it's funny how these things pop up, right? This is a really good test case. And I'm quite thankful that it was reported in this level of detail. Like, I was given a full move list. Um, so I was able to just drop the moves into the Lichess importer and say, okay, have at it. Produce me a move list. From this move list, I can get the FEN. From the FEN, I can generate the test case and so forth. So it's not too much work as long as I know what I'm doing. Initially, I was quite beside myself about the way it was reported, and then I understood what I was doing. Oh, I'm sorry, that didn't show on the stream at all. I have to show you this again. Yeah, I was able to import the game into Lichess, get this test position. So here it is. And black's in check, and he sees that there's this pawn that's not defended. And so the rule is that if you can make a move that captures, you have to capture. So another test case that'd be fun is if you stuck a pawn on a5 and saw, like, is pawn takes bishop generated. That could be another fun test case. I tried moving the pawn about a bit and seeing, like, what Stockfish came up with. It was only this case so far that was discovered as broken. So here's what we do. So get checkout master, then benchmark, and I'm actually going to deviate a little bit from what I did last time. Actually, I wonder, is there a way I can take multiple sets of positions as my benchmark? Like here I say FENs equals this array. Like, is there a way I can get more than one index out of the array and test that? I'm not sure. FENs.size. Wait, this is an array, right? Oh, it's a vector. Oh, well, that makes my life easier. So here's what I'm going to do. It's quite similar to what I ended up doing in my patch. So FENs is equal to defaults variant. I guess that's okay. If variant is equal to losers variant. Again, I'm typing with without the aid of all of my fingers here. One is still in a band-aid, but I can still type. So if the variant is the losers variant, fens dot insert append whatever it is, default of chess variant, rep variant star.h. So what was it? Losers variant versus chess variant. So I did get that right. So yeah, for losers chess, the benchmark is going to be what you would normally do, plus tack on all the standard chess positions. Now I don't remember for vector or string how that's supposed to work. Make clean, make build, optimize. Well, yeah, let's just put the architecture in here and allow it to optimize. And I know I do have running tests on here, but I don't care. I'm going to use all my threads. I do understand the fish test is going in the background, but what can I do? Oh, append. Well, that's too bad. Benchmark, that should be append or insert or something. Okay, let's compile that. Try that once more. Nope, nope, nope. All right, so C++ add array to vector. There's got to be a way to add an array onto the end of a vector. Insert. Okay. Maybe I want to just search for Stack Overflow. Because I think insert only takes a range, like C++11 allows for a position and an initializer list. Yeah, I'm better off just checking out Stack Overflow here. Come on. Really? Really? Okay. Seriously, somebody give me better help than that. Oh, it's the same question. Okay, we're gonna get caught in semantics. Oh my goodness. I'm not even wanting to convert like a vector to array or convert an array to a vector. I want to append an array onto the end of a vector. I guess I have to make two vectors and append each other and whatever. If that's the only way to do it. Oh, vector. Wait, no, that's how I create the vector. Otherwise, standard copy with resize. Yeah, I'm not going to do any of that unless like somebody gives me a concrete example to follow. Many answers, and all of them will do. There's a lot of misleading advice. Here are the options. Copy the array using the back inserter. Same as when pre-extend the vector using reserve, memcopy, insert. Okay, insert is something I can do. Yeah, I'm not going to make two separate vectors if I don't need to do that, because that's just hokey. We're not doing hokey stuff here. Alright, so we want to do fens.insert, fens.end. Let's see, what's the syntax on this? Array of data array 0, data array size. Okay. I suppose I don't necessarily know the size of that array very easily. Wait, no, I do. And that's uglier than just making a new vector. So I'm going to make a new vector for sake of code readability. I don't even care what order I have the things in. But yeah, vector insert is the best for that scenario. Well, we'll see how this goes. So, address of chess variant 0. Address of chess variant and then we're going to need something -1. That's something being the final index, the array size. Oh, size of divided by size of that. Yeah, sure, whatever, that works. Making a Lichess for you. Actually, not Lichess at the moment. It's just Stockfish. But yeah, we're working on loser's chess, or losing chess. Alright. Int. Number of elements. Equals. Size of. default chess variant divided by size of string. That's not going to work either, is it? Oh, wait. No, these are... Yeah, no, what's the size of a string? Man, I don't want to have to count how many are in here. And this could always change, too. Yeah. We're not going to do the efficient thing. We're going to do the inefficient thing. FENs equals defaults variant. Wait. Is there a syntax here? FENs plus equals defaults chess variant? Please tell me somebody overloaded that so I don't have to go define my own memory mapping operators. Please tell me plus equals for vector adding on. That's not defined. Okay, so you can do assignment, but you just can't do plus equals. I'm sure as heck not going to copy those. So, what was my other option? Copy using back inserter. Yeah, but I'm not copying an array. But pre-extend the vector using reserve. Any way I do this, I have to count the number of elements. Man. I want to do it in a way that doesn't require me to count. And everything I'm finding does require me indeed to count. And counting's boring. Alright. So we're just going to make two vectors and try to append the one vector to the other. Because there's no way to... yeah. That's fine. Position, comma, value. So, it's because I can't do this, what we're going to do instead is fens.insert, fens.end. If I use the new keyword, I have to delete it when I'm done, don't I? Alright, so vector string chess fens equals defaults chess variant, and then fens.insert, fens.end, and okay, that's one too many parentheses. This should say chess fens. That'll be fine. Technically, I actually wanted a prepend, but I don't really care. Inserting before the element to the specified position. Oh, so if I wanted it to prepend, I'd just say begin rather than end. As the, let's just do this at the beginning. So we're going to get through all of our standard chess positions, and then we're going to have some exceptional positions that we have for losing chess. That looks fine. That's if FEN file is default, we do that. Otherwise, we just leave things be, which is cool. Alright. So now if I compile, do I get anything? Please? Nope. Wait, do I have to specify the full range? Or the full range of stuff? Initializer list. Like when it says initializer list, there's no way it means, no way that it could possibly mean this, right? that I could just do like defaults, chess underscore variant. That's not an initializer list, right? Or is that an initializer list? No, that's not. I am curious about that usage, though. Usually they give an example of each one of these. Another vector.begin, another vector.end. myArray plus 3. See, a problem is I don't know the number of elements. So I'm forced to use a different syntax. Standard vector. In fact, let me try it this way. Standard vector string with initializer of that. Does that work? Substitution failed. Okay, no matching function to call for basic string insert. Alright, so yeah, in fact I do have to explicitly call it out like that. And then say chessfins.begin, chessfins.end. That was so convenient. Please tell me that works. Okay. I guessed correctly. I'm trying to remember. There was a computer science expert who gave a speech, I think a PhD even, who gave a presentation, not a speech, but it was on the subject of just the last thing that you need in C++. Or I'm sorry, the last thing you need in D. And he was a C++ expert giving a talk about all the things that are challenging in C++ and how he has to advise companies about everything they have to consider when they're upgrading their software. Let's just make sure I didn't break that. And so he was speaking of all these idiosyncrasies in the standard template library and how each author that's part of that collective that maintains that library. Okay, cool, that works. Awesome. Well, I have to get back to that point now because I'm actually making progress. I was thinking that would take forever. Okay. So this is just the standard starting position. We don't need that there. We need this position as a test position. And the idea is that we're going to assemble several of these test positions. Let's see. Like one where we actually have a black pawn over here. So let me add a pawn on A5. So rank 8, 7, 6, 5, where it says 1p6, that's now going to be pp6. Black to move. That needs to pass. Curiously enough, I thought that Stockfish was going to crash in this particular position. Oh, I forgot. Okay. Well, let's try this. Let's do our compile, and then we'll go back and prove. I was forgetting. I was doing some testing earlier this morning and saw different results, and I understand why now, but we'll get back to that in a second. So he was giving this speech, and yeah, each author of the STL has their own set of priorities, and they do prioritize everything as a high priority, but when everything's the highest possible priority, contradictions happen and compromises occur. And this leads to confusion and fragmentation within the library because there's no perfect way to maintain that library. And so examples are where you have, I don't even remember. You have to go check out his speech. I need to remember his name, but I don't. So, in fact, here we still pass testing. Um, that confuses me. How did this work? Okay, what if I comment out this line here? And we'll get back to the full test later. But yeah, if you want to sort, for some collections you call stable sort. For other collections you just call sort. When you want to insert an element and you want to call like, I forget if it's append or in place or insert. And there's all kinds of reasons for these discrepancies in the library. Some of them are just that it's not possible for everybody to talk to everybody else and perfectly communicate everything. Alright, so there we are. Position 1 of 2, info depth 0, score mate 0 was the issue reported. Issue reported was illegal move, game lost. In this position, after bishop takes b4, the program couldn't find a legal move. And yeah, that's actually correct. I mean, the way you reported it wasn't... Oh. Legality checking on. I didn't even know there's a way to turn off legality checking. Rather, I know there's a way to turn on debug mode. But even when you turn that off, there is still some legality checking. Like, you're not allowed to put your king into check. So yeah, I took that test position, demonstrated that before bishop takes b4, the engine was saying, oh yeah, just put bishop takes b4, it's a good move, that's actually checkmate, and then after bishop takes b4, that's game over. Now checkmate is kind of different in losing chess because you want to have your king in check and not have any legal moves, so you lose. You win by losing the game. So, what do we have here? Oh, and then I moved the pawn, and that all worked just fine. No big surprise there. And yeah, Fabian Victor fixed that one particular use case. And now what I'm going to do, like I've been saying I'm doing, is building up some test cases. And then we're going to run both engines on them and see whether they both pass the tests. So, another fun test case. I'm not sure that this is in the bench. It's probably not. 5 minutes. Probably nothing here for tricky use case I'm thinking of. So let's get a new board out. Actually, let's leave that board there, get a new one, in case we ever need to go back to that board. Alright, how do I clear the board? How do I clear the board? I guess I go to the board editor, which is really what I'm more interested in. I don't care about actually doing moves, I just want to set up a position. Yeah, I hope so, but we'll see. We'll see. I hope mine works. We'll put it that way. I'm really not optimistic that Fabian fully considered everything, because it's tricky. Alright, so say we got... How am I going to do this? White to move. Say black's got a rook here, and a pawn there. And okay, let's go to the analysis board from here. Let's say, oh, well, shoot, I spoiled it. It needs to be black to play. Black this board. All right, black plays d5. So what needs to be tested here? Interestingly, oh. Okay. Very clever. I forgot about that. I was going to say I need that move history here so I can get the en passant square out of the fourth set Edwards notation, the FEN. Um, yeah, because the rook's there, I'm not going to get that character, that D6 character. So this would normally say king, queen to say castling rights. And then this would say D6 is the en passant square. Um, so admittedly, what I'm trying to do is construct a bad test. This is actually going to be interesting because I'm not sure. Oh wait, no, here's how I can do it. Oh shoot. It'd be the initial position and then the move d5. Although the move d5 is not even legal there. Right? I'm going to need to be trickier than this if I want this to work. So how do I test this? This is going to be actually much trickier than I thought to set up a position where white makes an illegal en passant move. It's doable. It's just not very easy. So we're going to set up black's king. So we want to... Oh, wait. What I'm thinking of with en passant is not a real use case, is it? So it'd be a situation where a pawn is pinned to white's king. Like, this isn't going to work either, but I was thinking, what if we had something like this, and then black plays e5, something like this rather. Black plays e5, and then white captures. There's my arrow. But that's not a real use case, because if this pawn is pinned, well, okay. This is tricky. This is what I was thinking about. Oh, but this is... we get a bishop pinned. We need to pin it differently. Now we're talking. So this is legal. And this is legal in response. Or at least it should not be legal in response. Yeah, chew on that for a moment. I'm going to use the washroom. Let me mute the mic before I do that. Alright, we're back. So, admittedly, when we've got this sort of thing, chess interface won't tell you that e6 is an en passant square because that's actually pinned. That's not a legal en passant square. Um, so, like, if I go, what? Not load position. I want to say black to play. We go to the analysis board. I'm going to play e6. And note how this FEN string does not have the e6 square in there. Oh, okay, I got it back. Cool. So I want to see if I can do like this. Moves e75. I'm not sure if that notation's accepted, this way of doing things. King c8, you say. What's this about king c8? I'm not even saying like what's the best move here. I'm just saying like I'm trying to break the engine. And so considering we're playing losing chess, the case to test here would be if I play e5, the engine should figure out that rook takes bishop is better than pawn takes pawn. In fact, rook takes bishop's the only winning move there, but there are two legal moves. I could further complicate. Well, I can't even pin the rook. Because if the rook's pinned, then black's obligated to take it. But black cannot capture in the situation where he plays e5. It would only be like if somehow we'd have a situation where e5 or c5 or something were legal. We'll get to that in a minute. We'll get to all the tricky stuff soon. So, let's see. FENs. Okay. Position.set FENs I. Now, I'm not sure if that's going to work for processing a move list. I'm almost certain it won't, but what do I know? What's our definition of set? Set FEN string. I assume this just takes the string and doesn't handle any of the moves after the string. Castling, set castling right, en passant square, 3 check positions, move number, full ply. Yeah, so it's not gonna pay any regard to the moves thing. Hey, Penguin GM bot. We have a bot talking in our channel, guys. Welcome. So. FEN. It's a string. Oh man. That's so messy. No, unfortunately this is not the Lichess desktop app. Sorry. Oh, actually, yeah, that's a good point. I don't necessarily need to specify the moves in that test. That's where I was going next, is that if this was prohibitively expensive to find a way to get the moves embedded here, we just do that. And force the engine to figure out that e5 is losing because of rook takes bishop, but e5 with the other moves is not legal. Loser's chess is not anti-chess. Loser's chess is chess where you have it's basically all the same rules as chess, except your objective is to lose all of your pieces and all of your pawns, so you have only a king remaining. It's a really weird variant. I didn't think it was that popular, but apparently people on the free internet chess server play it. So, It's a thing. Um, yeah, the end games in that variant are quite interesting. It's a mess. So here we go. I'm gonna see. In fact, I can make a test file and just replay the test file here. I don't necessarily need to put every bit of this into the benchmark, although eventually, well, we'll get there. We'll get there. So let's vim test.txt. So set option name UCI underscore variant value losers position fen this moves E75 set option name multi PV value 4. Alright, let's just bump that all the way up to something pretty large so we get all the moves. Let's start with 2. See if 2's enough, and then bump it up if we need to. In fact, yeah, there should only be one legal move in this position anyway. Go depth 10. And then you can see you can dump that to the console. You can pipe that into Stockfish. And it says that rook takes b7 is the only legal move. The Stockfish is not challenged by this at all. So this particular position did not trick it. That does not surprise me. So we're going to go back and try to make this a little trickier. So this is what we were looking at, black to play. How do I do this? Let's put the king over here, put a rook over here, and a bishop. So, and then we're going to put the white king over here. So black's going to play e5, and what we're testing is that pawn takes pawn en passant. Removing 2 pawns between the rook and the king is illegal. You think it could handle this one? Note that black cannot actually capture the pawn here. That's why I pinned the rook. Alright, black to play. Let's grab that. I'm also going to add this to my test suite. So there it is. 0, 1. Okay. Go to our test thing, position, fen this thing, moves, e75 again. Play that. a4, b5. Wow. That's amazing. How did that work? I'm impressed. This has even tripped up the official Stockfish team at various points. This kind of, I'm doing an en passant move, and oh look, there's not a single piece between the rook and the king, so therefore I'm okay. But no, en passant is a little bit trickier because it removes 2 pawns, but no, apparently Stockfish handled that just fine. Okay. I don't understand how Fabian's code handled this. This was what I was worried about, is that it wouldn't, and then things would get really complicated. But no, his code seems to work just fine here. So it's amusing that the position that failed was this position, where the king takes pawn is illegal. But the other position, where we got the en passant and the 2 pawns that are in the way, and how could it possibly know that it's going to have to remove both of the pawns, and how's that ever going to work? It handled that just fine. Can anybody else think of some really challenging positions? Because otherwise, I think we're good. I was concerned that Fabian's approach, where he said, "Oh yeah, just take your coding simplification and apply it on top of mine, and all the search numbers should match up 1 to 1." And there's no need to go troubleshooting any of that stuff. But I was about to react that, gosh, you missed this use case. How could the other use cases possibly work? But no, apparently he handled it. I think we're good enough. We can always add more test positions. So this took... Okay, how long have I been here? I mean, I did hit the restroom once, but we've been here less than an hour. The first 10 or so minutes was me just highlighting a stream, having breakfast, and getting ready and warming up. But I think this is passing with flying colors, much to my surprise. I can't think of any other tricky positions to throw at this. Because most of the positions where an en passant move is even considerable, in those positions, well, we'll handle things one at a time. But most of those positions, black would have a capture available. Here he doesn't have a capture available. Yeah, it seems pretty solid. It seems solid enough that if he says take your numbers and my numbers, and they should be the same numbers in terms of we have a same common start position, and we're generating all the legal moves from it, all that should work out just the same in his as in mine, as in Fabian's version of this, in his initial implementation, where he just happened to miss the one really uncommon thing and somehow managed to handle everything else. And that seriously surprises me. But okay, he did it. So, color me surprised. Is there anything else I can do to try to trick this up? No, I don't think so. I can't, like, have a discovery through the black pawn, unless it was along a file, but anyway, I think we're good enough. And yeah, if players find anything in their testing of the engine, that works too. So let's recompile. I don't even need the -J6 here because there's only the one file to be built. So we can handle one file at a time. So built benchmark.o, and that's using that to build the Stockfish binary. And then from that, we're going to run the bench. If that bench works, then we're going to add in all the standard test positions just to verify it doesn't break. If that works, I think we're good. Yeah, I don't even need to drop into debug mode and show any bugs or anything. So that's cool. So yeah, benchmark. 64 milliseconds, it got through the 4 positions. Only got tripped up by the first one of these positions, but this is test-driven development. We're defining the tests and then writing the code to go fix them. So I'm going to inform the other developer, Fabian. I propose 1. Good idea. I propose 1. I augment. I add tests to benchmark.cpp to I merge. Actually, doesn't matter what order I do these in. His pull request does. We're about to find out if it addresses the bug. And merge your PR. Yeah. I'll just put that all as one step, even though it's really two. To I submit a simplification test. The difference between let's see, it'd be great if you could split your patch into two parts. One where you rewrite the move generator but can capture losers and search.cpp. This is not change bench and perfed, since it's supposed to be no functional change. In a second commit, you can then remove can capture losers and replace it in the search. He's really caught up about having that particular method. Let's see. I really don't like the whole thing of breaking my change into two separate changes, because that doubles the complexity of my change. I mean, it might help with regressing some things later, but we've got CVS. When he's talking about search.cpp, we've got... Oh, okay. Now I understand his motivation. It's for performance reasons. He wants to do it his way. I'm not going to do it that way. I'm not having a thing in position.cpp that says, that has all this logic in it. For, like, extra code. If I'm submitting a simplification, this is going to be gone. The king could only capture undefended pieces, loop through possible captures, and so forth. This is just too complicated. I'm okay. All right, stay dry. I'm not gonna keep that there. I submit a simplification test. I submit my entire patch. I test my entire patch as a simplification. Including removing can capture losers, which is a bit complicated, which is a bit complex. My patch must have the same bench numbers. as the new master. Must have the same perfed numbers as master. This commit should not change bench and should not change perfed. Oh. Wait. What is his reasoning? I'm struggling with this one. This commit should not change bench and perf since it is supposed to be no functional change. And then I can capture losers and replace it in the search. Wait. Oh. Okay. Okay, I now understand. Okay, so yeah, the whole point. Alright, so rewrite the move generator. Let's see, and can capture losers and test perf and test bench and perfed. For I replace can capture losers and submit 3, 4 combined. So that my entire patch has a simplification. Actually, if it's a simplification, does it need to go through the whole testing yaya? I don't know. Ay, ay, ay. I mean, it should be a speed up. Yeah. What a mess. Alright, so I suppose I'm not logged in over here. Let me log in. Where's my login button? Alright, so we're logged in, so we'll drop back over here. That's not where we ultimately needed to go. Ultimately, we needed to be logged in where? Oh, here. Just see, like, this is pending, but he's not approved it. And while I'm sure this is fine, there's no need to do that test right now. And test my entire patch as a simplification with bounds -6, 2. That seems reasonable. I will merge your PR. add tests, rewrite the move generator, and replace can capture losers. Okay. So I have some confidence that his patch is going to fix everything and not break anything. He's tested it. It's good enough. Let's accept it. So fix number 239. Merge it. We're good to go. It's merged. Okay, get status, get stash clear, get stash, get branch dash V. Okay, get branch delete fix underscore losers, get pull origin master because origin is GitHub. Alright, so we've got his fix there. Get stash apply. Okay, then benchmark. Well, let's recompile again. So we got to build benchmark.o. Oh, how many of these do we have to build? I didn't think much source code had changed. No, it'll take a second. Or two. Apparently a header file changed somewhere. Or somehow a lot of, yeah, a header file changed. Okay. So that's cool. We'll get back to my big old patch in a minute. So there is value to what he did. It would have been useful to use his patch as a way of testing my patch. I suppose ultimately we're going to do that. Okay. So we've compiled Stockfish bench losers. Okay, 181.707. Yep, that fixes position 1 where it was not finding king c5. Now king c5 is legal there. So that's cool. Get diff shows what I'm about to commit. So I got rid of the original test here. Say we're going to add on the standard chess positions and some losers chess. I was just testing that as it was just for the losers variant. Let's do one big old test here. So but yeah, having that defect where most of the moves work, but this one particular position doesn't work, really helped me open up the hood and find everything that was causing that particular issue. And yeah, it was certainly possible to go into the header file and fix it the one way, but I chose to fix it my own way and then look at his solution. And we didn't come up with the same solution, and that's okay. So our new benchmark, which includes all the standard chess positions plus some losers chess positions, 233-2039. That's our new benchmark. Stockfish bench will produce the same bench numbers it's always produced. Just the number with a lot of 5s and 8s. Yeah, 5885815 is our current bench, or our current number of nodes that are searched for all the benchmark positions for standard chess. So get diff one last time here. So that's cool. Is there anything else here? I think that's good. I think that's a reasonable set of test positions to be adding. So get status, get add benchmark, get commit, add benchmark positions, add more benchmark positions for losers, chess. Let's add losers variant benchmark positions. Yeah, that's fine. No functional change. Well, whatever. I mean, we get that the bench, all the performance of the main search routine is the same. It's just that if you try to actually play games, you get different functionality. Git push origin master. There we go. It's even better than what I originally did. All right, so now we can focus on trying to test what I did. So which branch was it that applies to this? It was losers generate moves. Git check out losers generate moves. Git branch. Oops, no. Here I want to say get rebase master. Obviously there's a conflict. Git status. Then benchmark.cpp. So here we got all our conflicts. Lots of arrows indicating what happened. So we're going to stick with that. That's good. Get add benchmark.cpp. Vim position.h. So what changed here? Oh, he kept, yeah, he's got his function still. Yeah, I guess we're going to keep this can capture losers thing for now. Get status, get and position.h, get diff search.h or cpp. Actually, what's our status now? We got 4 files. What has changed in search.cpp? Oh. Okay. That's strange. Apparently, whatever. That's cool. Get reset head. Search.cpp. Get check out this. Get status. Okay. So yeah, a lot of my changes are still in place. Wait, what have I changed here? Which files? The move generator for one. Position.cpp and position.h have changed. What have I changed there? Move generator, I don't care about. Let's take a look at position.cpp, position.h. I'm trying to figure out, does he want me to keep anything in this position.cpp? Oh. Obviously I can't get rid of that in position.h. H. Get check. Get diff. Get checkout. Head of position.h. No. Get checkout. Just that head that way. So we have the one thing remaining here. Oh no. Zug has food poisoning. Wow. That's no good. I mean, I've eaten some pretty terrible things before and felt pretty bad because of it. Terrible as in more spoiled than I thought it was. Not just having bad food. So, yeah, it's just the bad cases that you do remember. So, so for the purposes of what I did here, pseudo legal. I'm debating, is this part of my move generator change? Or do I have to leave it be? It probably complicates my life to leave that. So... Ay, ay, ay. This is going to be messy, because when I start pushing this change, you have to do it in pieces. See, I kind of consider this to be part of the... wait, what was the motivation again? Is that the search itself would not be affected. Here, in order to generate legal moves, I'm generating moves in very specific, uncommon, extremely uncommon use cases. But I'm doing more move generation to prove whether or not a generated move was legal. Like, I get leaving the search alone. I'm still struggling with, is this something I'm going to leave as part of my initial changes to the move generator? What else did I have in this change? Get diff cached. I mean, there's everything I changed in the move generator, deleting a lot of code there, adding a lot of code elsewhere. It performed pretty well when I was done with it, but I didn't actually compare before and after in terms of performance. Position.cpp. Yay. Maybe I want to have both of these here, which is kind of crazy. Well, no, I don't. I don't want to get rid of just for. Get stash clear. Get stash. Oh. Actually, I'm still in the middle of rebasing. Continue rebasing. Yeah. This is how we're going to be doing that. Get status. Get reset head -1. Get stash. Get stash applied. Put the change back. But now I have a stashed copy of it There's probably a better way than calling stash than stash apply, but we're going to say movegen.cpp is part of this change. Get status. Oh, actually, is that the only thing in position.cpp? Is that the only thing there? Because if so, I don't have to make that part of what I put on. Yeah, I can separate this, is the key point. Right, so the code will compile without this change. Git commit. Oh, okay. Where was my commit message? Where'd it go? Remite, move generator, and benchmark. Okay, git commit. Rewrite losers move generator. I'm not actually rewriting the benchmark anymore. Yeah, that's fine. It's just the move generator all by itself. So that's what I want there. So next, we still have position.cpp not merged yet. So we're going to remake the change to search.cpp. We're going to use git history to help us resolve all this stuff when we're done. So my comment I had over here it is. Something about pseudo legal moves. Do not prune if a capture is pseudo legal. Is the comment I want to add here. Okay, can capture losers. Across my code base, go to position.cpp. Oh wait. I don't remember removing that. Oh, I'm sorry, it's in the .h file. That's where it is. It's gone. Gone. Except it's still in the git history, so I can go restore from the history and test things that way. Git add position.h, status, git add all my CPP files, git diff. Looking at what am I about to commit. So I'm ready to commit. Validating normal non-captures. Getting rid of this big old mess. And is this function that I want to get rid of anywhere else? No. It's not in any of the source code anyway. So now we say hey, internet get stash, get freebasing. Yeah. So having to go out to GitHub to go get the code change that I had earlier, shows that I did not properly do things the Git way, but what I did ended up working somehow. As long as this compiles. That's the critical test. Does this compile, or have I, in my zeal to make things better, made things worse? As I often do. Gosh, how far back do I have to go to get a compile command? There we go. Make build. Build my stuff. We can always rewrite history if we need to. We shouldn't need to. Oh, this is the case where I want to use git stash. Okay, so first of all, I'm just making sure, have I not lost my changes? I've not lost my changes. Git status. So the best way to do this would actually be to stash those changes and then do what was suggested. Git Stash clear. Git stash makes me slightly nervous, but there's always the copy on GitHub in case I really F this up. So now if I do another compile, it'll see all the files that I changed. Compile only those files which need to be rebuilt, which I think is most of the files because many of them do use position.h, and position.h is one of the victims of my change. Okay, so both of those versions of the code do compile. And 2 for 2. Okay. Now we're going to say Stockfish bench losers. And we get a bench number of 3270585, right? Oh, crap. See these last two where it says mate 0. That means it's screwed up. Like, there are some legitimate stalemates and checkmates in here. But according to what he's saying, according to what Fabian's saying, is that let's just be able to follow what he suggested. Just this here. Adding the tests, rewrite the move generator, keeping bench and perfed. And then I can capture losers with my entire patch. And it's step 3 here that failed, where I'm attempting to rewrite the move generator but keep his code there for the sake of trying to get the same numbers. And that just doesn't work. He promised it would work. Okay. Well, that's no good. So now what? How long do I stick with this approach, trying to find a way to make it work? Capture losers. Return false. Well, I mean, stalemate should be possible, but the positions we were looking at this morning had nothing to do with stalemate. There should be at least one move played in each of those positions, or at least there should be a legal move in every one of those. Yeah, so my usage of this pseudo-legal method, I actually use this as part of my move generation. So I can't do things exactly as was prescribed. Get status. So I think I have to do something slightly more aggressive. Get stash apply. Just to verify, we got my stash. Now if I build, let's make -J6 to build faster, using all 4 cores, doing 6 tasks at a time. Not really 6, but between loading things from disk and writing things to disk, it's best to have more than 4 things in the queue at a time. Alright, so it builds everything, and then if I redo the test, I've still got my original code here. So this should work. This is me applying steps 3 and 4 of this recipe that we agreed to. But step 3 should have worked by itself. At least what he's saying is that my changes shouldn't have broken something such that whatever. And this is just kind of optional, trying to get things to work exactly as he suggests. Wait. don't I have my same code change? What's gone wrong here? What gives? Well, it's good I put the tests in there, isn't it? So, for those just tuning in, this is one of our test positions. I don't have my LeChess board open anymore. LeChess editor, here we go. Drop in my FEN. So, certainly black has a legal move here. Black's legal move is e5. There's, like, no question that e5 is legal in this position. This bishop's pinned. And so the bishop being pinned should prevent bishop takes pawn. So something in my code changes is not working as I hoped. Okay. So next thing we do is add the argument debug equals yes when we compile. So let's rebuild everything with all the debugging flags enabled, such that we get a lot more testing, a lot more coverage. Actually, before we do that, let's focus exclusively on these new positions, right? So if 0, we're going to add in all the standard chess positions. We'll get to that in a minute. For now, we're just going to test just the loser's chess positions, and make sure that we find legal moves in every one of those. I mean, clearly the issue is that when I'm searching for captures, I have failed to consider the fact that some of my pieces are pinned. But how did I fail to consider that? We'll find out. So, bench losers. Okay, that failed. So, unfortunately, it didn't even provide a stack trace or anything. The program didn't assert that there is a legal move here. I could add assertions into the bench, but that's not good enough. So let's take this test position, test.txt. Position, FEM that. Yeah, look, that's our first position there. 0, 1. All right. Black to move. Show me 4 variations at a time. Go Stockfish, go. And it finds nothing. So, obviously my testing this morning was a bit shoddy if it missed this. So we need to go into movegen.cpp and figure out where in all my loser's chess changes did I break something. Okay. Generate moves of type captures or quiet moves or non-evasion moves. So here I speak of what we do if we're looking for captures. Apparently I have to validate a move here. Like elsewhere in here, we check for pinned pieces, right? So I guess that same concept is going to apply. Wait, it's in position.cpp that we define the pseudo legality of moves. So the very end of this method or function, we say we're going to validate normal non-capturing moves. So if there are no checking pieces, we're going to see if the captures contain this move. I think that's wrong. It needs to be if the captures contain a legal move, then a normal non-capturing move is illegal. So that was a bit hasty. We're in position.cpp, so we don't have to call this POS to get all that info. Let's see. Do we have a move list somewhere? How do I declare a move list somewhere? Apparently I have to create my own declaration. That's okay. Oh, we got some kind of link here. What is it? Oh, Komarov's commentating. Very nice, very nice. Yeah, I tend to... I do usually... I think Nightbot allows links that are on Lichess. It just doesn't allow arbitrary URLs that it has to go through the Google URL shortener to go find stuff. But maybe this URL is something worth adding. Oh, okay, yeah. Yeah, that's Dmitry Chess. I could probably whitelist that at some point, although I'm busy coding right now. Move list. I guess move list is going to be what we call this. Let's move list this. Let's see. Oh, I'm sorry. There's a place in search.cpp. Yeah, here we are, where we iterate through legal moves. So that's what we're going to do. We're going to copy that here and say we don't even need to get pinned pieces at this point. Let's see. Well, actually, it wouldn't hurt. Bool validate is going to be yeah, we need to, well, this is more complicated than I thought. Yeah, I don't know how Nightbot works in terms of that kind of moderation. Oh wait, this is normal moves. Okay. So, let's see. If m.move from is not equal, or wait. Yeah, so we're going to say if there's no intersection between move.from and pin, or if we find the move to be legal, which I think is tested this way, return false. So keep iterating through the captures, trying to find something. If we do find something, then that's that. I think that covers it. Oh, I'm sorry. It's not move from, it's from square. Like we see down here. This is from square of m to square of m and so forth. So if the piece we're moving is pinned, or if it's not pinned, or if the piece is pinned, but it's legal to move the piece anyway because there's no, because moving it doesn't put it into check, does not put the king into check, then we're okay. Okay, so I think that was the core of what I missed there. We're going to find out in a second. Oh, that shadows a parameter. Dang. Well, we can't be shadowing parameters. Also, I was not interested in this. Actually, wait, why am I doing it this way? A normal non-capturing move. We can capture. Why am I not just doing that? Because effectively what I'm doing by doing all this am I pinned and so forth is copying code that's already in the move generator. Like for example, here, if we're doing a move that's like en passant or castling or something silly like that, we're going to use the normal move generation process and use its output. In several places we do just rely on the, I guess, the legal move generator. So yeah, if we're playing loser chess and the move that we're making is not a capture, and if there is the circumstance where it looks like we can capture something, there's a pseudo-legal capture out there, then we need to ensure that we're not that our move is still considered as legal. We need to do a more exhaustive kind of search there. So this compiles, right? First of all. Second of all, does this work? And third of all, is there a better way to do it? So it compiles. This test position still fails. So that's not it. So yeah, before I get focused on what's the best way to do this, I need to focus on what is a way to do this. I still not have found a legal or a good way to do this. Okay, let's disable the whole block. So that's a lot less checking on our part. Still not a legal move. Nary a move to be found. Let's make sure that we got the test position right. There's our test position. Black to move. Not a legal move to be found. Okay. So that's to say that my move generator is bunk. Unless there's something stupid in position.cpp that's somehow causing this to fail. I can't imagine that being the case here. Well, okay. Let's simplify this just a touch. Let's get rid of all the other variants. or at least everything not related to like anti-chess. So atomic, bug house, crazy house, horde chess, king of the hill, loop chess. Loser's chess is going to stay because that's what we're testing. Racing kings, suicide chess, 3 check. There we go. Just those 3. And in fact, actually, yeah, we don't need any of that. Losers is independent. It's got its own set of rules that don't fit so well under the anti-chess umbrella. So I could say recompile, but it's not going to do anything because it doesn't consider that it needs to rebuild everything when I change the make file. Okay, so yeah, there's a lot of unused parameters, a lot of warnings. Can capture does not exist in movegen.cpp, or does not exist in position. Position.h can capture. Oh, sure enough, that's an anti-chess construct. Is that going to be the only thing that fails? Uh, 475. I'm not even sure if I need that check. Let's take it out for now. We can always add it back if we need it. Is that the only thing that fails? Search also has that failing. Search.cpp, line 873. Also uses that particular method. So for what do I do now? I guess I add anti-chess back in, or yeah, can always add this back later. Always skip pruning. Do not prune, period. We don't need prunes here. Okay. There's a difference between pruning and wrinkled raisins. Or prunes, or whatever. You get the idea. I don't know what prunes are. It's some kind of fig. I think if they dry up, they become raisins. Okay. Still, did not find a legal move. So, what am I missing here? Evasions? Nope, we're not concerning ourselves with an evasion move. What are we looking at? This is still evasions. Generate. If the move type is not captures, let's see if we got a capture. Do I really have to check for pinned pieces here? I think I do. I think that's my issue. Well, gosh. Prunes are dried plums. Raisins are dried grapes. Figs are fresh figs or dried figs. Oh, who knew? And position.legal is this capture. Actually, wait, why am I doing things this way? So, I am interested in, are there any pawn moves? And are there any captures or non-evasion moves? So I was trying to really tune this for performance. This is a super aggressive performance tuning change that probably should not be all done in a single commit. So generating captures generates all the pseudo-legal captures and queen promotions. Will not generate under promotions, just queen promotions, and returns a pointer to the end of move list. Generate quiets. Generates all pseudo-legal non-captures and under-promotions. Returns a pointer at the end of the move list. Generating non-evasion moves. Generates all pseudo-legal captures and non-captures. Also returns a pointer to the end of the move list. So, I was attempting to overload what I was doing here, saying for quiet moves, if a capture is legal, return an empty list. For non-evasion moves, if a capture is legal, return the legal captures. But I'm presuming here that the capture is legal, and that might not be the case. Does this specify a set of target squares that we need to hit? Okay, this gets to select the target squares. But let's take a look at the thing that generates all the legal moves. Generating legal moves sees, am I in check or not? If I'm not in check, generate non-evasions. Otherwise, generate evasions. The way it does that, it actually just calls generate evasions or non-evasions directly, does not specify a target. So if I'm looking for evasions, well, no, I trust that evasions work, but non-evasions would be the code that I was just looking at. So if I were to call legal moves, it would just end up calling non-evasions, and I would have an infinite loop, so I can't do that. What else could I consider? Okay, so what we normally do is call generate all for color and for a type of move, type being captures, quiets, or non-evasions. I guess the most efficient solution is to here add that. I really don't like having to add the legal move check because that's kind of got a recursive nature to it. However, captures in only one case are promotions. So I have to have some way of validating these promotions up here. I'm sorry, these are en passant moves. These are not promotions. And these are not under promotions here. So it's still possible that a promotion exists in this, but it would be covered by captures or by non-evasions. Non-evasions generates all pseudo-legal captures and non-captures. So all includes both promotions and under promotions that are done by capture and all that good stuff. Let's see, my quandary here is that if I go back to the legal move checker, it falls back to calling moves.legal in some circumstances. Wait, right? Or am I making that up? Move list is called from pseudo-legal, but actual move validation does not call the move generator. Okay, I thought there was something confusing whereby it was actually permitted to do that, but it's not. It's just doing a brute force check right here. So yeah, that brute force check should work. And it does not require generating an entire move list, so that's a relief. So, good news is that really good testing tools are in place, so I should be able to submit things that just completely suck. It might be somewhat expensive to call position.legal, but not as expensive as getting things wrong. make sure you have the correct result, and then tune for performance later. All right, let's compile. Okay, draw values not used right now. Still don't find any legal moves. Okay, so we're gonna have to start making more and more drastic measures here until we find something that works. So, next thing we do is comment out this entire block. We're at this point searching for how do I get it to generate as many moves as possible. It's possible a good many of those moves could be illegal. There we go, we've got some moves. So is that the only thing I changed in this file? No, I did change the whole move evasions routine, which is the more complicated part of this, but that doesn't matter here. Okay, so something inside this block of code somewhere is the problem. That really narrows it down, guys, doesn't it? Okay. So, if our move type is non-evasions, and we have a legal capture, it baffles me how that capture bishop takes pawn move could be considered legal. I don't understand that. Oh, wait. Oh my god, I'm an idiot. We all are. Alright. Well, it's easier to theorize about programs than to actually write them. We can leave it at that if you're okay with that. Okay. Yeah, I try to do tricky things here. So I said, like, if we found some pseudo-legal moves, then go ahead, iterate through that list of moves. Oh, this isn't going to work either. It's going to fail for a different reason, which is pretty great. Like you were saying, it's all Greek to you anyhow, but I need another pointer. Okay. That's what we need to do, I think. Yeah, it's pointer math, guys. Yeah. Not sure what more to say about it. Oh, actually, I don't have to do that. Move list does have a size attribute. So I could say if move list dot size. Move list is a pointer. No, it's not a pointer to the list. It's a pointer to a move that's in that list. So I actually do have to do it the way I was just showing. If current is not equal to move list, etc., etc. But current's invalidated up here for ext move pointer cur2 is equal to cur. Current is not equal to move list, and so forth. So we got two move pointer things. There we go. This is saying if by the time we're done with that, we found anything, then we're going to return the list. That's disgusting. I'm going to do it differently. Bool capture equals false. If we found something, not only are we going to increment the pointer, but we're going to remember that we found a capture. After we found that capture, There we go. So if we found a legal capture, then we remember that we found a legal capture. And we return the move list containing that capture. Otherwise, we just keep going with our normal search. That should be good enough. Alright, compile. Okay, that compiled. Test. Alright, that's something other than nothing found. Stockfish bench losers. Position 1 it found something. Position 2 it found something. Positions 3 and 4 it found something. Okay, cool. Test. Let's see. Git diff. Okay, here's that whole if zero stuff I put in there. Leave that there. How many places in the code did I put this if zero stuff? 2. Alright, so validate normal non-captures. Let's try that. So when we, oh, hang on, I'm missing something here. Can capture is still not defined. Line 1020. Whoa, cool, I just activated help mode. Okay. Help mode with a P at the end, that is. Okay. Oh, actually, I was saying, let's separate that can capture thing. You can always come back and try to integrate that back in later. 1026. Oh, yeah, and then I was saying this is kind of a mess. Why even do it this way? This is the thing I meant to keep controlled in this if zero block. So then let's compile that. Okay, and then run it. 1, 2, 3. Okay, cool. So wait, we're in pseudo-legal. Pseudo-legal doesn't need to do any of this validation, does it? Pseudo-legal doesn't check, am I putting myself into check? This is entirely redundant. Entirely redundant. Because the whole point of pseudo-legal is that checks, takes a random move and tests whether the move is pseudo-legal. It's used to validate moves from the transposition table that could be corrupted due to concurrent access or hash key aliasing or whatever. It doesn't actually check, am I putting myself into check? It just sees, like, is the move even halfway sane? I mean, that's oversimplifying it. It actually checks, like, is this considered legal according to the rules? Oh, right. This would still need to see, is there a legal capture? So, if there is a legal capture and we're attempting to make a move that is not a capture, then that makes this move not legal. Obviously, well, okay. First of all, let's compile and test that the code still works. We're going to have to tune that later. Okay, so code still appears to work. I haven't looked at the bench numbers, but they're twice as high as where they started this morning, but we're getting better results, so status would say which files I have under revision, git checkout, let's revert the make file, make clean, recompile everything with all of the flags on. I could take a look at that can capture stuff. I think can capture just says, do I have a piece that's attacking another piece? But I'm not sure if that's more or less expensive than just going out and trying to generate the capture moves. One would think it should be less expensive to see is anything attacking anything versus seeing do I have legal moves for any of my pieces that happen to be captures of opponent pieces, but maybe it doesn't matter. In fact, why do I bother with that? Alright, so get diff, or get stats to show me I have 5 files under revision. One of those is the benchmark file, so I can kind of write that off and ignore it. Get diff position.h shows me that I'm getting rid of that method, can capture losers. Get diff movegen.cpp is really the heart of where we started this. Oh, there's an extra space in there, but more importantly, I still have this POS can capture thing commented out. So I need to think about that. Let's get rid of the extra space, because why not? But up here, do I need to do a test for is any piece attacking any piece, or can I just do what I'm doing here? What I'm doing here should be fine. I don't think I need that check. That was just me trying to over-tune this for performance, and I ended up complicating it too much. But this should be okay. So this is trying to generate moves that have destinations of where my opponent's pieces are located. Plus, trying to generate en passant capture moves. And let's see. So if we were asked to do quiet moves, that is non-captures, then we're going to go search for capture moves. Otherwise, if we're asked to do non-evasions, which is just all the legal moves, we're still going to look for all the legal moves, but filter it by occupied squares. I mean, this is really, really tuning for performance here. This generate the captures is just done so... In fact, what's the difference? The difference is if I have under promotions that involve captures, then I'm not doing under promotions that involve captures. That's probably more efficient than I need to be. That's the point of only doing non-under promotion capture is legal, return an empty list. I have gone over column 80. I mean, it doesn't even matter what piece you promote to. I should just say return all legal captures here. If any capture is legal, return an empty list. Okay. That seems fine. That seems all fine and dandy. Arguably, I could skip this step if I already found that there was an en passant capture that was legal. I'm not going to bother with that complexity. This is as readable as it's going to get. I think the presence of an en passant square does not guarantee that captures are legal. Just FYI. All right. All right. So what has changed in this? Okay, we got rid of that POS can capture stuff. We're checking was a capture found, and if so, return the list. Which in the case of quiet moves should be empty, and which in the case of non-evasion moves should contain all the capture moves, including under promotions, including en passant moves. Alright, get status. This is where we're at. Get add move gens at CPP. Get diff should indicate I haven't changed anything that's going to adversely affect the move generation. Search.cpp, and we can figure that out later. Git log. Okay, git commit, adding in my changes. Whoops. Write that, save it. Okay. So the move generator's been committed. Git stash clear. Git stash my changes. And now I should be able to make clean and make from scratch again. Here we go, compiling my code. The move generator itself should be fine. Yeah, it was actually a really good suggestion from Fabian. I didn't understand it. It seemed like more work, and at first I didn't appreciate the purpose of the change. But now I think it's okay. And keep in mind, this is all still in my local repository. I've not shared this on GitHub just yet. So people looking there might not see this code change until I push it. I know I had an older version of this change which apparently didn't work exactly right. So Stockfish bench users. Oh right, I forgot I had that. Okay, we're gonna change the benchmark file to skip over the boring stuff so we can get to the interesting stuff. If 0 and if there. Recompile. All right. Position 1 of 4, we found stuff. 2 of 4, we found stuff. 3 of 4, and 4 of 4. All right. We found legal stuff in every one of those positions. So the move generator seems to pass. Well, okay, now we go back, check out the benchmark file as it originally was, recompile, and test all 46 positions just to make sure that Stockfish doesn't blow up. So, yeah, downtime. No, it wasn't Richie. Now I'm trying to remember, who was it? I'm still trying to remember the name of that PhD who gave the talk. He's very well regarded in the field as C++ and computer science in general. Obviously he's got a PhD, so he would be. But he was invited to the D conference to speak about just how it's important to consider design considerations in a language and in a program. And that if you're going to make anything that lasts for any real period of time, you have to give a lot of consideration and thought to the right way to do things. Yeah, let me see if I can find the name of that speaker. Here, new window, switch, go back. Okay, on my new window, YouTube dconf, the last thing D needs, C++ PhD. Scott Myers. Scott Myers is that presenter. Yeah, it's a really entertaining 1 hour, actually not even an hour. It's a really entertaining speech. He puts up all these slides and points out all the various things that he's run into with C++, that he's had to explain to anybody who wants his consultation. That, okay, yes, there are a lot of things that simplify some issues, but there's some really complicated questions you have to ask when you're upgrading code or changing your compiler or just doing really advanced system migration sorts of things. You have to be really detail oriented. I know some of this that I'm doing looks pretty advanced. In terms of this particular code base, I'm sure it is. In terms of programming in general, this is just C++. This is just working with one tool, one language, one set of testing tools. This is not so complicated for anybody to pick up. It just takes a lot of time. Also a reminder, hopefully I don't forget this, but this afternoon I'm going to be playing some Bug House. Yeah, I got invited by Atrophied, Snatchpado, and ChessWiz. So we're going to play some Bug House and do a dual commentary, quad commentary, whatever it is that you want to call it. I think it would be most entertaining, and unfortunately technology might not provide or permit for this, but just have everybody on one big call and just banter over the whole thing. But that would not be very instructive. I think more instructive would be if you had if each team had its own consultation, or if you had 4 independent videos of people giving their perspective on the Bug House game. I think Bug House is more entertaining when partners are not allowed to communicate with each other directly. Like, no typing, no talking, no nothing. You just play the game. It's not how it's meant to be played, but I think it's the most amusing way to play Bug House. Another amusing thing to do in Bug House is just annoy the heck out of your partner in a very public way. It's like, ask them if a queen trade is okay, and after like an instant's worth of consideration, say you didn't reply and go ahead and exchange the queens. Now, sometimes this is just a mean thing to do. It's just playing around, being silly. But no, sometimes you're in a position where you don't have any choice but to trade the queens. So why not ask your partner? Although the more polite thing to do would be, say, the queen's incoming and I can't do anything to stop it, and that sort of thing. Alright. Now, did this fail on one of those intermediate positions? That went quite quickly through some of these intermediate positions, but nothing wrong there. All right. Yeah. If you're with a good partner, the banter can get quite entertaining. So I actually am going to have ChessWiz for my partner. The only thing which might make it slightly less entertaining is the fact that we're up against some really strong opponents. So We might get pummeled on pretty badly, but try to have fun doing it. Oops, don't need to do cached because I haven't cached anything yet. Okay, benchmark, like I said, I can change that back. Position.cpp. Oh, this is my refactor to improve performance. Okay. Wait, how did my previous change work without this? Validate normal non-capture moves. This should have been part of my move generator code. How could my move generator code relied on this code up here. So I didn't have to do generating all the legal moves to figure out if we had a capture available. So now I see why there's a can capture losers method. I think there might be other constructs in position.h that allow us to know if things are attacking stuff. Apparently not. Apparently not. Well, that's a pity. We're able to know if pieces are pinned to the king, but we have no way of identifying is anything attacking anything. That's not something that's cached. Is not having that cached something I can work around? Like, surprisingly, well, I mean, a lot of these are methods related to variance, or functions related to variance, but yeah, it's curious that we've got check info, we've got a state, we've got castling rights. We just don't have is anything attacking anything. Well, well. Well, if something's not in the declaration, I'm not going to find it in the rest of the file. That's the whole point of having a declarations section of the file. Wait, do I have a state info? I do have a state info. What's in the state info construct? Okay, there's a comment here. Stores information needed to restore your check to move. When a move is made on the board, a state info object must be passed. But this doesn't keep track of is anything attacking anything either. That's why we needed that whole can capture function method thing. And then there's can capture losers. I don't want to generate all the I don't want to generate all the legal moves. I could generate all the capture moves to figure out if the capture is legal. But I'd like to think there's a better way. Yeah. That's unfortunate. So, pseudo-legal has that stuff. Yeah, I can understand why you generate all the legal moves in order to figure out if some really uncommon, like promotion or en passant or something is legal, or pseudo-legal even. But in terms of doing that just to figure out if we have a capture at our disposal or not, that's a bit complicated. Oh, alright, I'm just going to look at movegen.cpp. See, where do we bother generating captures? generate, which takes a move type or a gen type. I think this is what I'm looking for. So I bypass this whole routine. If I'm only generating captures, I don't need to verify that. Well, you get the idea. Don't need to check if I'm making captures and filter out non-capturing moves, because I'm ultimately going to end up only with captures anyhow. Do I need to do anything in here? Passing in a position and a move list. I don't think so. There's quiet checks, there's evasions, there's legal moves, so... Oh, even generating legal moves passes in a move list first, which I think is somehow done through the move list's constructor. Right, so... Oh, but if I'm generating captures, are these capture moves themselves validated? That's the thing I'm missing here. Say I bypass this routine. Then I do generate all my captures, but I in no way validate them. That's bad. That's really bad. Bad, bad, bad. So maybe my solution is I just fall in here anyway. And I need to, well... So now if I'm doing the validation here, like I had to check, can I generate capture moves for any other type of move? For quiet moves and for just all the moves. I have to see, like, can captures be done? So there is that dependency there, but if I'm generating just captures, interesting. So I skip that whole routine. I just make all the captures and don't even bother validating any of them. Yeah. Like I could see if a function asks for give me every quiet move or give me not every non-evasion move. I absolutely need to check that for legality. Something asks me to give me all the capture moves. Well, I need to check that for do I have a capture move at my disposal? And the way I'm doing that right now is really clunky. It's generating all the captures this way. I'm now it's just starting to dawn on me just how immensely complex this change is. So what do I do? I was quite hesitant about doing anything related to this in the first place, but seeing the engine doing an illegal move just really had me thinking. But no, this can't capture losers, as complex as it is. As much code as it duplicates, or might duplicate, this is probably the fastest way to do it. He actually had a really good intuition here. I just thought he was not so familiar with this code. I mean, I guess there's nothing wrong with this, because most of the time the captures list is going to be empty anyway. The way I did it here protects against is if somebody asks for quiet moves and then tries to check their legality. Like, where was this change for checking if a move's legal. Like, he changed some code in pseudo-legal. He doesn't have any code in... Well, he doesn't have to. Because, like he was saying, he's getting moves out of the transposition table. So the move has to be a playable chess move. In a global context. But that's not to say that every move that's available by transposition is necessarily legal in loser's chess. Just because you can play a non-capture move one turn doesn't mean you can play it the next turn. Even if that happens to be a move that's possible on the same board with a very similar position. If somehow you have a capture at your disposal, that takes away from the legality of your move. So it's possible something's buggy about the way search is working due to really subtle reasons. So this kind of check has to go somewhere. And I put it in the move generator. Ultimately, it doesn't belong here, does it? For the same reason I just described. Guys, we're going to go over to the legal move checker. Position legal. Tests whether a pseudo-legal move is legal. Oh, but that says that it's... Well... I don't know. Like, I'm not so sure about that. I'm really not so sure about how this works. So we've got the move generator uses that. Wait. Oh, that's weird. Why did that not find the matches in position.cpp here? That's got to be something interesting about regular expressions or something I don't know about. Let's get rid of the -w. So, I'm not so interested in these calls to pseudo-legal, but I'm curious where we call legal from. Because we can get moves out of the transposition table and then check if they're legal. And we already know that they're pseudo-legal because we get them out of the table, I think. This is where things get complicated. So move picker, which remembers some really strong moves, does check for pseudo-legality. Move gen obviously does all kinds of advanced stuff. Position.cpp. Wait, legal relies on this. Where does it say that? And then search. I think I'm looking for position.h, right? No, I'm actually looking for position.cpp. Relies on this. Evasions generator already takes care to avoid some kinds of illegal moves, and legal relies on this. We therefore have to take care that the same kind of moves are filtered out here. That does not give me a warm, fuzzy feeling. It's news to me that legal sometimes relies on pseudo-legal. I'm sure I was the one who added that comment too, which is kind of disturbing that I don't remember what exactly I was talking about. like, okay, another example of where a pseudo-legal move is no longer even legal or pseudo-legal would be if you had an en passant move. If you don't play it that turn, it's not going to be there next turn. Granted, that's really specialized stuff, but still worth noting. Okay, stop the search if only one legal move is available, or if all the So, alright. Do not prune if a capture is pseudo-legal. Okay, what are we looking at here? Prop cut. If we have a good enough capture and a reduced search returns a value much above beta, we can almost safely prune the previous move. So if move, which has gotten out of the move picker somehow, move picker being has a position, has a transmission table. This doesn't even say how to use the move picker in this context. Who knows how we're using it? If we have a good enough capture, I mean, this is something where this is just an omission, really. We don't want to be pruning like this in losers chess. We don't prune like that in anti-chess. We don't prune in losers chess based on having done a capture. That's just an oversight. Loop through moves, loop through all the pseudo-legal moves until no moves remain, or until a beta cutoff occurs. Legal move, Singular extension search. If all moves but one fail low, extend that move. Okay, so this is a singular extension node, and move is equal to the transposition table move, I guess. I'm not sure. And it's itself not an extension. And if the move is still legal. Okay, where did we get move from? Where did we get move from? Okay, loop through moves, loop through all pseudo-legal moves until no moves remain or until a beta cutoff occurs. So we got to move out of the move picker again somehow. However, it was most efficient to give us that move. This is step 11, right? Or how did I lose that? Here we are. So we're looking at step 11, loop through moves. Move picker, next move. Just whatever happens to be the most efficient next move to give us. And we're checking here. Okay. Why do we do something special for anti-chess but not for losers chess? Let this settle in. What's this about? Oh, this is a specialized thing for anti-chess that says if we're going to make a move and our opponent's going to capture us next turn, and this move itself is not a capture, then do a one-move extension. That seems generally useful. I'm not going to add that for losers chess right away. Really not motivated to do much in the way of improving that. Okay, just want to make sure I'm not going to break something, really. Check for legality just before making a move. Check for mate and stalemate, etc., etc. Check for legality just before making a move. Legal moves have been searched. Okay, well, I think we've hit all the points in the code where we check a move for legality and then stuff happens. So, again, what have I haven't put anything ready to commit just yet. Benchmark is still going to stay how it is. Position at CPP, I'm still struggling over, do I need this can capture losers thing or not? I'm starting to lean toward leave it in. and don't write my own way of checking that. Because this is pretty complicated. This is saying, checks whether we have a legal capture in a loser's chess position. And that's not easy to do. I mean, that is so extremely difficult to do that I was thinking, surely whatever this is achieving can be done more efficiently through the move generator class as opposed to trying to doing it here. I was absolutely certain and confident that this is just a very complex and difficult and challenging approach. And honestly, I'm surprised that this code exists at all. Because it seems to be redundant of the move generator. Like, what is useful is a method that says, can I capture anything, period? And then, if you see that there's potential to capture something, then just ask the move generator what's going on. But, this is more efficient than the move generator, but this terrifies me. This is just complex, man. I don't want this complexity. Yeah, so I'm going to go back to position.cpp. I know it seems like I'm chasing my tail here. I know it certainly seems that way. Okay, we're going to re-enable this. If there are any checkers, we got to do like the whole legal move generation business. Else, if we're not in check, I mean, I think either way, probably what makes the most sense is, yeah, this sort of thing. Except we're not going to generate all the legal moves. We're just going to focus on, can I find any kind of capture? And if I can, then we're good. If that capture itself is legal. Is there anything special I got to do here? I don't think I need this business of consult the legal move thing, and because we can check a move by itself if it's legal. I think this is ultimately what we want to end up with. But only if there is an appearance of something being able to capture something. But that doesn't matter. We don't need to go to every one of our pieces and consult that all. And yeah, we'll just do... I don't know. We can worry about those details when they become relevant. First is just verifying that this approach works at all. So is it else if 0? Or is it elif? I don't remember. There's a way to say like else and else if and so forth. But yeah, whatever. It's clean enough. We can clean this up later. Make all my captures. If I found captures... yeah, so I think I've come up with an even cleaner way to do this. Movegen.h So see, there's all these kinds of things here. If def losers, and if we're going to add one more, which we're going to call legal captures. This way, position.cpp doesn't need to concern itself with how that all works. Just with making legal captures. Move gen.cpp. Actually, I could take this whole stuff here. This is a legal capture generator. Is it not? It's very much as a legal capture generator. So, okay, where's one of these simpler things? Here, let's take this. 653, 647, these are like 9 lines apart. Right. Delete those 9 lines, stick them on the end here. Nope, not there, here. And then we're going to say legal captures if def losers. We're going to have this code in here. And it's going to do stuff. Actually, this should have an underscore to follow the convention that's used everywhere else. Everywhere else being non-evasion moves. This is just a useful thing to have in multiple places, so... I suppose I don't need this whole, if I'm doing quiets, look for captures. Well, no, this is fine. Aye. Aye. See, now I'm getting to code duplication because, well, so I need to say, yeah. There is a better way to abstract this. I don't know it at the moment. So I'm going to avoid further abstractions until said time that I figure that out. In the meantime, I do need to go over to position.cpp. And I guess I'm keeping this. I guess this is going to be what I test. I keep trying to think if there are better ways, there are better ways, there are better way, but ultimately this is okay. Probably from square has already gotten some. Yeah, we have from is from underscore SQ. Oh, guys, we got heavy winds. Promise those heavy winds aren't me. Okay, pinned pieces of us. Is that something we have cached? Okay, we do have that cached. That's fortunate. Pin pieces and from is the standard form, I suppose, so we'll do it that way. So, for each move that's in that capture list, if the piece that's moving is itself pinned, or the move itself is legal, then we have a legal capture, and therefore the other move that was previously generated just doesn't work. It's probably good enough. Make J6 build architecture equals x8664 BMI2. Lots of files getting compiled here. And then, oops. Ha ha. Ha ha ha. Does not work. Okay. So we shadowed a parameter. So over here, like I was saying, that needs to be move rather than m. Wait, is move also a parameter? No, m is the parameter of this method, so we're going to make that move. That's more like it. Capture is not declared in the scope, being 1025. Oh. That's right, because we call this captures rather than captured. Never mind. I mean, look at this. MoveGen.h. Compilers are picky, too. So there's legal, and then every one of the other ones here has a plural form, but legal is itself a singular form. The grammar. Okay, 1025. Move list in this file. We generally use the this pointer rather than saying POS. So we'll point to this, build again, and this is what we're testing. Are we finally ready to test? Finally, after 3 hours of coding, are we ready? Are we set? Can we go? Okay, I still have time before we do our bug house. Stockfish, bench, losers. Okay. Test 1, test 2. As long as these all come back with something, I'm satisfied. Alright, so far so good. Wow. I know I've been flying back and forth and equivocating all over the place. And I've been repeatedly saying just ignore benchmark.cpp there. So here's what remains. So we have position.cpp, where we're checking pseudo-legal moves, trying to get rid of this can capture losers thing, and try to just use the standard move generator instead and validate the moves that come back. I think if I tidy that up, that's done. I don't think anything remains to be done there. We've got position.h, where I got rid of this can capture losers thing, which is equally complicated as what I'm doing. And then we have search.cpp, where I identified a condition where we're pruning and we shouldn't be pruning. And still haven't decided there. So one decision remains to be done. What to do about this position can capture method. So what was the context of this change here again? Search.cpp. I don't even have a line number to go with that. That's unfortunate. No matter, I can search for that by text. Just by looking for losers. Okay, do not prune if a capture is pseudo-legal. So earlier the compiler complained because this thing is only defined if you're compiling with anti-chess enabled. And I had anti-chess disabled there. I think this is still the correct condition. We don't need to have a separate thing to check, like, do I have a actually legal capture in terms of should I be pruning? I think the pseudo-legal version of that, that anti-chess defines, would more than suffice. It's really a bit overkill to do what we were originally doing, in my opinion. And how we're going to test that is I'm going to submit my entire code change to the fish test server. So we started this off looking at GitHub, looking at the issue, seeing that 2 patches had been made, and the ultimate test is going to be, we're going to compare those 2 patches to each other in terms of performance. I'm doing my patch my way, and my way is we're going to change the logic here. So we're going to skip search pruning if there's a pseudo-legal capture, as opposed to skipping search pruning if there's an actually legal capture. Because it's such a piece of minutia, such a small difference, that I don't feel like having 2 completely independent methods that check for anti-chess, which would be giveaway, suicide chess, and all that. Do I have a piece that's threatening to take something? And then for losers chess, have a separate method. Do I have a piece that's threatening to take something, and oh, by the way, is the piece that's threatening to take something itself pinned in such a manner that it's not able to perform the capture? That's pretty specific. I don't think that should be part of a general search heuristic. So, that said, that means that when I'm compiling, I need to have anti-chess if I'm going to do losers chess, which is no big deal. I just have to say here, that if you're going to compile for losers chess, you also have to have the anti-chess code. So how we test that is we do what I initially did, which was remove anti-chess, make clean. Oh, see? It works. It works too well. Okay. I probably should even add something in here that says, you know, if you're doing make clean, don't bother like doing any of this checking. It's only if you're actually trying to compile something that you need to do any of this checking here. Do I have a way to check if I'm cleaning? I don't know. That actually gets complicated. Never mind. We're going to leave that be. Make clean works. And now if I try to compile with just those 2, everything should compile. Yeah, you might get some warnings, but that's because this code base is a bit complex. And you know, if this compiles and runs, then I suppose it would make sense for me to do the tests in the order that they were recommended to be done. Just to recap, step 1, done. Step 2, done. So we've merged his code, we've added tests to the benchmark file. Step 3, rewrite the move generator. Done but not tested. And now that I've got 3 and 4 together, I'm going to go back and do just 3, making sure that if I execute the bench Does it have to have the same bench? I'm not sure. Probably. Right, because if the search itself isn't changing, then we're going to hit the same number of positions in the bench test as we're done in his PR, this pull request. And certainly perfed should generate the same numbers from the start position for his change and for my change. There should be no differences in the number of legal positions. And the number of searched positions should also be the same, I think. Pretty sure, but not entirely sure. And then step 4 is submit my stuff to the server and see how it goes. So we haven't finished step 3 yet. Now that I've built up some confidence in both steps 3 and 4, I'm going to go back and do 3. But first, make sure I haven't missed something stupidly obvious. So 1, 2, 3, 4, all these have legal moves. Get status. Okay. In makefile. So I was going to revert the makefile, and I just remembered, wait, I just added some code into here to ensure that if you're doing loser's chess, you got to have the anti-chess code. That's new. It's okay. Alright, get checkout benchmark.cpp, because that has that change. I said don't worry about it, I will revert it. Well, it's now reverted. Let's do another test. And this time, I'm just going to run through all the bench positions with my combined 3 and 4 code. This should trivially pass. There should be no problem with this passing. Okay, what do we got? Probably a whole bunch of warnings. Make clean. Try that again. Hey, Mr. Corrupted. How's it going? You know, it's funny. A while ago on XKCD, they had a comic. Where was it? Here? Is this going to get me to it? Yeah, so some words have... well, okay, this wasn't even what I was looking for. Some words have a greater affinity to wanting to be pronounced in English, I guess. Verbal programming. Can I find this? Nope, nope, nope. Verbal something, language, pronounce. I misspelled it, but Google knows what I mean. Yeah, whatever, I can't find the thing. My point was that some words have emphases on appropriate syllables, and oh, guys, come on. Loser's Chess was already merged. There was one extremely subtle bug which was reported this morning, and you know, while we're in there fixing it, I'm really going to dig in and get rid of some code that I don't like being there. Even though it's probably fine on its own, but... Besides, why haven't you written the relay chess code? No, it's hard to write. It's extremely hard. I'm not giving you a hard time about that. You don't deserve that. Alright. Position 1, 2, etc., etc. Man, this is boring. And this is the optimized version of the code. It's actually somewhat troubling that it doesn't do this faster. Like, if I just go back and say Stockfish bench, 1, 2, 3, 4, etc. But you see how slowly it's doing this for the loser's chess version. It's still on position 2 there. That's a very terrible sign. So I was saying I'm ready to go back to step 3 and do things exactly as suggested. But my code is underperforming. Like, really badly. So, what do we do now? Yeah, I think this check, which I removed, like I said, we could come back and figure out if there's a performance issue, and if there is, introduce this check back in. I'm reintroducing it now. So this is in position.cpp, if 0. Oh my goodness. Wow. Okay. Now I feel dumb. Only do this capture stuff, or only check if, yeah, I don't know how that code worked there. But only check a move for legality if, you know, the move's not already a capture. If the move itself is a capture, we don't need to go find all the captures. That's really inefficient. Okay. Let's compile that again. Oh, now we're missing an end if somewhere down here. Okay. Let's compile that again. This should be more efficient. Should be way more efficient. If anything, loser's chess should search positions faster, or search trees faster than normal chess, because there's not so much to search. These benchmark tests are benchmarked to like depth 13, I think. The only thing that's slow here is waiting for the compiler. Alright, so let's try that again. Position 1, position 2... Oh man, it's still stuck. Still. So this is the part where I was saying, you know, if it's still underperforming, then we'll add in this part. Even though that required me to change the make file, and now loser chess requires this can capture function. That's okay. Compiler couldn't figure out how to be smart enough, so I have to provide more and more hints to the compiler as to just how chess works. That, you know, don't bother trying to make capture moves if nothing's attacking anything. That's correct. Yeah, loser's chess has all the same rules as normal chess. In terms of if you're in check, you have to get out of check, and you can't castle out of check, and so forth. However, if you can capture, you must capture, and your goal is to lose everything other than your king. So this is very different from giveaway chess. Like night and day different. And apparently people on Fix still play this. Alright, so we're still spinning our wheels here. I really don't like that. That's boding extremely badly for the upcoming performance test. Comparing my change with, drawing a blank, Fabian's change. Yeah, it's a fun variant, but it's extremely frustrating to play because often you get stuck with one pawn and your whole game becomes about how do I get rid of this one pawn. Well, I think this busts my theory about how to optimize things. It seems like we do need a general purpose function. That's really sad news. I mean, I've learned stuff about all these coding changes throughout all this, but yeah, this is really bad news if I can't use the move generator there. I'm going to hit the washroom one more time here and be right back. Alright, so got my water here. You can hear the microwave over there heating my lunch. So I'm looking, is there any more room to optimize this stuff? Well, there's the whole checkers code. Um, like if I'm in check, I don't need to be generating all the legal moves. Well, no, that should handle itself automagically. I shouldn't have to worry about it. Yeah, there should be very little functional difference between looking for captures versus um, looking for legal moves. That's the whole non-evasions routine that's called for when I'm not in check. Um, so, I was just assuming that the legal move checker um, performs well. One sec, let me make sure my food is heated up and I'll be right back. This is the interesting part of the code here, though, if you can figure it out. So some people like barbecue food. I've got teriyaki. So you basically just heat up some chicken, pour on the marinade, or you could marinate the chicken and heat it up the way you're supposed to. Either way, it's chicken with teriyaki sauce. So who doesn't enjoy that? So yeah, I'm just staring at this, seeing have I missed something? Is there a way to slightly improve this to perform better? Or am I going to compare this for performance against how Fabian's code works and see how I just completely missed the mark? Like, my impression was that Fabian's code tries to generate a legal capture move. And so, if we're going through all the trouble of actually generating a move, why not generate all the captures? Is it really that expensive to generate more than one? Maybe so. Maybe not. I suppose most moves in this game are not captures. So maybe what I'm doing is super expensive. Maybe it is necessary to have a specialized form of this generator that just makes a capture. Or rather, it has to make a legal capture. I think this particular kind of code has no business being in position.cpp either way. It should be a utility method somewhere, probably in the move generator class. I just didn't think that this would have such a performance issue. But maybe it does. For sure, this is a lot simpler. If we have a move that's not a capture, and if we have the appearance of being able to do a capture, then this can't be legal. Oh. Oh, wait. One thing I could do is we do have a pinned pieces list. If none of our pieces are pinned, this would be an improvement for sure. This skips the whole move generation phase. If we are attacking something and we're not pinned at all, that's really bad luck on us here. That should probably help. Pinned. do we use pinned pieces in this class? Not very often. Still probably often enough that it's worth caching that value. If we're not pinned, do that. If not pinned in the from square, etc., etc. Okay. Let's try compiling that and see if it performs better. See, having food can help the mind be active. At least it works for me. If I'm hungry and tired and haven't gotten up and moved about in a while, yeah, generally getting up and moving about is helpful in itself. Having food is also helpful. Although probably a half hour from now I'm going to be a little bit less energetic due to that. But alright, position 2. How long did that take to complete? Is it still going? It is still going. So we see that after 15 seconds it's still churning on position 2. After 20 seconds it's still going. So that's way slower than, say, if I just do that. It's an order of magnitude at least slower. So let's go back to our loser's code here. Yeah, that's true. I don't want to be exhausted when we get there. So, I know the match is going to be at 4 Eastern, so at 3 Eastern, which is 2:30 local time, I'm going to make that my hard deadline for just saying, you know, enough's enough, we're going to play some games. And take a break from this coding and maybe get up and move a bit. Who knows? So we got some time before that. Still got a couple hours. I might even cut it at 2:45 rather than 2:30. Because who wants to wait for a half hour? Okay. If nothing's pinned, and it appears we can capture something, then yeah, return false, that's fine. Well. I think I did the best I could with this particular section of code. Oh, if we're in check. Let's see, if we're in check, we do need to evade the check. That's true. I've forgotten about that, but we are checking here, like, okay, if it appears we're attacking something, but if we're in check, then, fine, we could try this. I don't expect that to do any better. That'll make evasions, and the evasions are tuned for performance. In fact, the evasions already perform this kind of... Wait. I could copy some of this can capture logic into the move generator now. I might be able to speed up the move generator using that can capture function. Either way, these lines of code are now dead, so it's just down to this. Actually, I can't use the can capture function if we're in check. Or at least the move generator can't use that. move generator still has to make all the legal moves that would normally be legal, and then see if any one of those is a capture. I can't change. I mean, that was the initial situation we got into, I think, where we were looking for legal captures and not finding any, and then just concluding there aren't any legal moves. I guess I haven't shown you what I did earlier this morning. But movegen.cpp. Evasions. We didn't really cover this so much. So let's go there. So, we generate all our moves. And after we did all that generation, this is where it used to say just return the move list of all the legal moves. And I changed it. I'm saying now, we're going to process that move list. And if we find a legal move in there, I'm sorry, if we find a capture in there, then we're going to filter this down to just the set of captures. So that's what this is doing. And you could use this, in fact, I think to some extent we do the same exact thing elsewhere. But here we're not, because we're in check, we can't filter for captures up front. Elsewhere, here, we're saying do all this complicated stuff. Well, now that we have this can capture function at our disposal, because I've changed our make file and now we can't deploy loser's chess without deploying anti-chess, only bother with this nonsense if it appears that we have the possibility to do a capture. I don't think that's going to affect performance at all. But I guess since I'm changing the code, I'm going to fix one formatting thing down here. At the end of generate moves for evasions, I'm going to get rid of the extra new line there. So yeah, now I'm changing the move generator to only generate, only do any of this nonsense if we have a threat to capture anything. Then go ahead, make all the capture moves. What I don't know about that is if can capture is actually accurate. I have not looked at it in quite a while. Flawed. Wait, if en passant square is not equal to none, and if we have a pawn that can attack that square, okay, we did actually account for that. That's probably a bug that was reported at some point, and that's still there. Okay, so that's cool. So let's compile the whole thing. I might end up rewriting some of the history here to say that when I'm changing the move generator, change it efficiently. It seems like such a simple thing to say, right? Like if I'm changing how we make our moves, make sure that the moves are made efficiently. That we're not spinning our wheels any more than we need to there. Not doing more iterations through loops than we need to. Okay, so that's just the normal bench command, just to give you a reference. 9, 10, 11, 11, 11, 11, 11, 11, 11, 11. Can we go to 12, please? We got 12. Do I have a 13? 13 going once, going twice. Sold for 13. Okay. So, all right. Oh, that's a fair point. Yeah. All right. Well, do enjoy walking the dog. Aren't domestic responsibilities fun? Okay, there we got 13. Going once, going twice. Yeah, there's no way that... I'm pretty sure that Fabian's code performed way better than this. I could be misremembering. Wait, if we can capture, then do all this. That makes sense. I mean, I could get rid of this. Sometimes do captures, sometimes do non-evasions. This might be overly complex. Ultimately, this probably doesn't even matter unless we have a capture that's also an under promotion, and in which case we want non-evasions anyway. But if all we're trying to do is just verify, do we have a legal capture? We don't need to get all the under promotions. Is there anything else here? Wait, we're checking, is the move a capture? That should be pretty obvious. Like, our destination square is either the en passant square, where we're doing a pawn move to that square, or it's a square occupied by an opposing piece. So of course it's a capture. Right? Well, that was silly. But I think that's why I didn't have the... well... Okay, if current is not equal to move list, check if any of the captures we found are legal. So this should not be capture, this should be legal. And if we found a legal capture, then we're in business. Then we're returning the move list. That's the distinction here. So I've found yet another way to improve performance. Though, surely it's not going to make any difference. An intelligent compiler, a really, really intelligent compiler, could have figured out that some of the code I just removed could have been stripped out automatically. It's possible some of the code I had in there didn't even matter in terms of performance. But, you know, it never hurts to test. 9, 10, 11. Going twice. 3, 4, 5, 6, 7, 8. Okay, we hit depth 12 at 8 seconds. I know we were saying this went for 20 seconds last time and I gave up on it. It's going for 20 seconds again. 23. Yeah, it's still at depth 12. So, how many nodes per second? We'll say 460,000 nodes per second. Previously, we were executing 420, 440. So I improved performance by, I don't know, several percent. Just getting rid of that one check. Which didn't need to be done. But we're still comparing to Fabian's thing, which is way faster. It's more complex, but it appears that complexity is warranted just based on everything I'm doing. It's Performance-wise, this is sucking really bad. Um, to put it in really technical terms that um, even the most refined engineers could understand. Yeah. Wait. If type is non-evasions and we have a legal... Okay, otherwise, yeah, we're just looking for captures as opposed to... Okay, that's the other thing here. Yeah, if we were just searching for non-evasions up here, I guess they're still destined to squares that are occupied. So why am I making this distinction? What am I trying to do here? I still need to check if cur is legal, regardless of what kind of move I'm looking for. I can't look for an evasion and see that the evasion's not... Oh my goodness. Chess programming's hard. So what I need to be doing, just for comparison's sake, I'll put that up here. Let's see. If position is legal, move. Oh, do I actually need an entire... Yeah, I think I do need this. So we got our braces. Position is legal. Then set legal is equal to true. And if type is non-evasions, we need to include the move, else we can exclude it. Oh, here's how we simplify this. We actually use negative logic. So if we have an illegal move, then we do something quite simple here. Oops, we're still using spaces because that's what the original author used. Continue. Else set legal to true, and if type is non-evasions, then we increment the current move. Else, well, we're still going to be pruning those out. Now, this gets into a point that, I mean, this is starting to look awfully complicated, isn't it? It's like I should have two separate branches. One that says if I'm trying to, if type is quiets, just check if we have any legal moves. That's all we care about. And another branch that if what I'm trying to do is see, get all the non-evasion captures, I still need to check every one of those moves for legality. Yeah, but this is showing the complexity that's involved in this stuff. Let's say if 1, do that, or if 11. We'll turn it up to 11, guys. Else, do the stuff that we were doing, and if. So, trick here is we want to keep track of somehow did I find any legal moves. And so a better way to do all of this than what we're currently doing is we're going to have another move is equal to current move. M is not equal to move list. And this is just going to iterate. Oops, I need my semicolon here. Oops. Unfortunately, we're still in C++, so syntax is always going to be a distraction. So this way that we're coding it, if position is legal M, well, I guess I have to dereference M. Then increment M. Else. We're going to remove the move from the list, right? It's the basic idea here. And then, if at the end of all this, maybe I do use my notation here. I guess I'm testing two separate things in separate points in the program. Right, so here I can't simply plus on that. I'm going to use cur2 because that's what I used elsewhere. And then here, if we find that our... Oh, so the problem with doing this, though, is it takes 2 passes. Yeah. Ultimately, it's going to achieve the same thing, just in 2 separate loops, as opposed to one loop doing everything. Still, these loops are pretty simple, but... this is the sort of thing you want to just trust the compiler to optimize for you. Yeah, I was going to say I could do some fancy stuff with pointers to make this smarter or simpler. But no, this is fine. Let's see. I mean, there's all kinds of ways to rewrite this. I want to rewrite it in a human intelligible fashion. As opposed to having negative logic, which tends to be quite negative. If position is legal of current move, so we're going to set, either way, we're setting legal to true. Oh, here's the point. We don't need to perform this check every time. If type is equal to quiets, and we have a legal capture, or this move is legal, set legal to true, and get rid of that move. No, that's bad. So first check. If type is equal to quiets, and we have a legal move, yeah, actually this is two separate loops. It really is. Because in the quiets case, we're going to prune out the move regardless what happens. So we say legal is equal to legal or position.legal of move. And then get rid of the move. And our other condition would be else if legal, set legal to true. And increment our move pointer. So here's our increment instruction. And our remaining condition is else, just get rid of the move. I think that's the most human readable form of this. So now the unfortunate thing about this is that, like, here we got two different ways that legal could get updated or set. One is down here through we found a legal move. Two is up here through we've got quiet moves. So this is where I was saying you could use two loops instead of one. The first loop would see, do I have a legal move? And then second would be processing the list. Or you could do it all in one loop, like we're doing here, where we don't have to do two passes through the list. We do have some added complexity here. But yeah, the benefit to doing this way is, like, it's pretty clear what's going on. Yeah, I think this is the most human readable form of that. The compiler can figure out how to optimize that. I don't need to. And then if we have a legal capture, just return the move list. And we're done. Oh, the other thing that's disadvantageous about this is this here. So what I'd rather have is add a continue statement here. And do this. And that's slightly simpler, though not perfect. Oh, I'm sorry, that's wrong. This is correct. So, if we're talking about quiet moves, we're going to check, is the move legal before getting rid of it? Else, if the move is legal, we're going to keep it. Else, get rid of the, or, yeah, if we get rid of the, if the move is legal and we're keeping it, continue on. By the end here, legal is going to be a check for, well, it's kind of a mess still, but it's our mess. Yeah. At least this only deletes each move once. Note that once legal gets set to true, it never gets unset. Um, and that's desirable. Yeah, I think we're good. I think that's as simple as that can possibly get, though it is quite complicated. 496 is missing a parentheses, or it has one too many, or it's just missing a dereference. Yeah, the only unfortunate thing about the way that's coded now is that it will check. It'll check. There's two different lines of code that are responsible for setting the value of legal. That's the really only unfortunate part of that there. Where was that? We were looking at move gen. Yeah, this here, the unfortunate thing is like, this should be true regardless of if we're doing quiet moves or not. The idea that we have any legal move somewhere. But we need also a way to check, is this particular move legal? Yeah, the compiler could probably figure a more optimal way to write all that, such that I don't have two separate calls to position.legal. Even though if I'm doing quiet moves, I don't care to evaluate this. I only care to evaluate this when I need to. We'll trust that the compiler did something smart with it. Probably something smarter than I could have done. Okay, so here we hit... Look at that. Isn't that beautiful? Trust the compiler. Always trust the compiler. It can do smarter things than you can. Okay, position 2 took a while, but the rest of these positions, it just flew right through it. So that begs the question, did I do it right? I'd like to hope I did. So we've got my bench number, my number of nodes searched, 5.77900. That should be the same number, well, if the search is done the same way, which it's not, that would be the same number. I'm able to do perfed losers. I'm not sure what that does. Oh, perfed doesn't accept a variant. But yeah, I did get a little bit tense there, I admit, seeing that it took so long in this position too. But after that, it just flew through these, right? It's like, if I cancel that, position 2 took, how long? 6 seconds for that position. Okay, but what's the bench number? Well, I'm sorry, we know the number of the nodes searched. What's the rate at which it's searching, or how long? This took 8.3 seconds to execute. Get status. Let's assume that it's correct, which it probably isn't. Get diff makefile. Okay, I didn't end up breaking the makefile. I didn't change the test any. Get diff shows all of my changes put together, including this use of can capture, which is quite good. Alright, so now I need to go back. So we had step 1 and 2 have already been done. Step 3 is rewrite the move generator. Well, you'll notice my most recent change ended up touching the move generator, but I can only do that if I also change the make file. right? So bear with me. We're going to go back one. Get status. Okay, we're going to say get stash clear, get stash. I know I'm not doing a get reset hard or anything. I'm just going to do get reset head -1 or head caret 1. So here we got the move generator. Get stash apply. Now we have to look at how my changes conflict with one another. Wait. This is the file, right? Local changes. Please commit your changes or stash them before you merge. Status. Oh. Well, that's unfortunate. So I have to commit it. I'm confused how to do this correctly. Alright. Get commit. Get add movegen.cpp. Can I apply the stash now? Okay. Yeah. Apparently if I stage my changes, I can apply the stash. Movegen.cpp and makefile. Get status. Okay, get diff shows the things that aren't part of the move generator changes. Such as the pseudo-legal function, I'm not so sure. For sure the header file changes are now part of that. As well as the search change isn't part of that. That's a separate issue, which probably should have been committed first. Or last. We can do that last. Get status. Okay. Get diff cached will show me what I'm about to commit. So we've got the makefile changes would say we can't do losers chess without anti-chess. Technically, that's not a subvariant. That's its own variant. Be really pedantic there. But yeah, there's this dependency between the two. Because I don't feel like having duplicated code. So you see here where we had this blank line and then return us and so forth. That's now been separated into move list is equal to the result, and then filter the move list and then return the move list. So that's now all together. We can take a look at that in, what's it? Generate evasions around 614. Oh, movegen. CPP 614. Down here, you see, like here, instead of returning that value, we assign it to move list. Strip out all the illegal moves, and then return it. Get diff. Oh, this is stuff I'm not including. Get commit. Okay, that looks fine. Status shows us what we have remaining. Let stash clear. Clear. So this is where we're at. Get stash. We'll put these changes to the source code files in the stash. Make clean We'll get rid of all the compiled binary stuff. Okay. So now we want to make sure this compiles. If this compiles, if this runs on all the test positions and generates the right answers, actually, I should have committed my more recent changes, and then we could go back and forward through the Git history. Either way, this is looking really good. Like, really good. Well, since we made that decision that to only bother generating the captures if anything's attacked. Or anything's attacking, rather. That was the turning point. When I was saying, gosh, it'd be nice if I could find one more way to improve this somehow. And then I found it. After having some lunch. So in some ways, coding in this way can be much like art. Okay. So wait, what? So we got my move generator changes. After my future changes, this test takes 8 seconds. Before my future changes, this takes 3.5. How is that possible? Seriously. What is it about my... I don't get it. Maybe it speaks to the incorrectness in my approach. Wait, so what's the difference between steps 3 and 4 again? Rewrite the move generator. Run bench and perfed. And then, yeah, so he approved this approach. Then replace this can capture losers and simplify that and make sure it passes testing. Git diff shows everything I changed. Incredible. Like, how? Okay. How is it that his code outperforms mine? I think that's what we're looking at here, is this getting rid of can capture losers. Requires calling this move list code. And this move list code performs badly. I don't understand. I guess the only thing I could try to improve performance-wise, or rather, performs poorly rather than badly, but you get the idea, right? This took 8 seconds to go through the benchmark testing. Oh no, it didn't take 8, it took 6. So it's not completely off base. It took 6 seconds instead of... so it's twice as slow. Not quite twice as slow. Less than twice as slow. It's a lot simpler. It's still pretty damn complicated, not gonna lie. But yeah. I'm gonna wager that if I just change this to do something really stupid and naive, this is gonna perform poorly. If one, else, and then we'll add our end if down here. Like, that's super naive. There's no way that that's gonna compete on these benchmark positions. It's just not possible. Yeah, I am starting to think maybe 2:30 should be my deadline for this, just so I have some sanity left when I'm preparing for Bughouse. So, yeah, that removing all that code there. Yeah, we've already hit 10 seconds and we're still going, so that's a simplification that does not help. It's better to go with this approach. If we have nothing pinned, still look for checkers. If we have nothing pinned but we're in check, we can't instantly return false. Is there anything else I can do here? If we're in check, and this move's not a capture, I think it still falls in the same category as everything else. Like, why am I doing this if we're in checked stuff? Can I remove that and perhaps do better? Wait, if I have no pinned pieces, we can't immediately return false unless there's no checkers. And here we're saying if the from piece is not pinned. Okay, yeah, so this whole thing about looking for checkers is actually kind of important. Oh, wait a second. Generating captures isn't going to generate anything unless those things will get us out of the check, right? No. Generating captures does not look for legal captures. It just looks for any captures. So yeah, and I think that's as good as it gets. Okay, certainly this approach fails, so we're back to this. I'm just surprised that this particular kind of thing, this, do I have any legal moves that dispose of the capturing piece, etc., etc., Um, this is outperformed by that can capture losers function, but apparently it is. And apparently in a very big way. Like, I can't slow down the program by 50% just to get rid of some code I don't like. Don't like in the sense that it's just pretty complicated, and it's going to make future development and future merging just that slightest bit more challenging. That can capture losers must have been really efficient. I mean, they say if you can't beat them, join them. Like, obviously, I could change the move generator to call the can capture losers thing instead of can capture. I just don't understand how that could outperform this actual move generator by that much. How many positions can there be where a capture appears like it could be legal, but it actually isn't legal because a piece is pinned or something? If we have pinned pieces, turn false. I suppose I could change this. Say if legal move, we got that. And then here I could say if we have nothing pinned and there's no checkers. Because that's going to cover a lot of positions. If we're not in check and we don't have pinned pieces and we're attacking something, don't even bother generating capture moves, because if nothing's pinned and we're going to capture something, I mean, just go ahead and capture it. Let's try that. I mean, yeah, one could define extremely complex logic, enumerating every possible circumstance. I'm trying to develop generic rules that still perform well. There's lots of ways to slice this. To give you an idea, there's a thing in computer science called a Karnow map. Yeah, here we go. So here's a way of illustrating a truth table, and you can divide up this space in many different ways. Some are more efficient than others. Well, oh yeah, and so we're talking about min terms for describing this. So, yeah, there's various ways you can specify this sort of thing, this kind of logic. And obviously what I'm trying to do isn't zeros and ones, it's like 5s and 25s and 37s and a whole bunch of stuff. And I'm trying to make a good compromise between all the logic conditions. And that's what the test is for. It's to make sure I don't have to enumerate everything myself. Okay, 4.2 seconds. Try it again. Can we get 4.2 again? We got 4.2 again. This is better than 6. So that's the trade-off here. So yeah, you can spell out every possible rule, but every rule you specify here is going to be one thing that might slow it down. And it's easier to do some kinds of checks than others. Like, it's easier to check, is my piece pinned, than to check, is the move legal. But this performs well enough. So without my changes, it takes 3.5 seconds. With my changes, it takes 4.2. I am ready to ship this off for testing, I think. I mean, I could go back every step of the way here and just make sure I haven't done something dumb, but the bulk of what's developed here is testable now in terms of running the old code, running the version Fabian wrote, running the version I wrote, comparing the two, and seeing which one, seeing if my version, which is simpler in terms of code, um, if it just underperforms like a lemon. And if it really sucks, then we'll go with Fabian's code until such time I can find a way to improve this. Um, is there a further way to simplify that? Like what Fabian did is he took this first statement here where if this is loser's chess and if the move's not a capture, he defined a special method called or function called is can capture losers, and if I have a capture, is it a legal capture and all that stuff. Whereas this code generates all the captures under some circumstances where we actually have to bother doing that. Oh, um, I mean, this should get inlined by the compiler. The compiler's pretty smart. Still, in terms of human readability, I don't need to have two lines of code that do one thing. And surely, yeah, we've already know who the side to move is. It's us, as we have that referenced everywhere else throughout this code. So if none of our pieces are pinned, and we're not in check, now note, here's this thing here, if checkers. There might be some way I could leverage that check going into this to say, like, if we are in check, do things differently somewhat. So there's a thought. I mean, the compiler will reorganize these statements as it makes sense to do anyway. But there might be something that's really so complex, so far in chess-specific knowledge that the compiler might not know to do it. Like this thing for pinned pieces us versus are there checkers. The compiler should expect that checkers is a simpler call than pinned pieces us, but it might not know that. It's like here, that's a constant. That can be gotten instantaneously. This, are any of our pieces pinned, requires a little bit of math. And since this is functionally equivalent, there's no harm in rearranging it. If for no other reason to help than a person understand it. But the compiler should figure out how to organize that statement. For human clarity, I'm putting it first, because that's what the compiler is going to do. Let's see, is there anything else? No checkers, no pinned pieces. I might be able to get rid of the pinned pieces check. I mean, now we're playing with fun stuff here, right? So the question is, do these two lines of code help more than they hurt? I'm sure that commenting that out, like I just did there, getting rid of those two lines of code, is probably going to cause more harm than good. But, you know, compiler could figure this one out. We don't have to. I don't have to guess it. It's two lines of code, a few seconds of compile time, many more seconds of actually running the test because it's not going to finish instantaneously. I mean, there's absolutely no way that commenting those lines of code out is going to improve things. But it might not suck. Okay, so that took 6 seconds. So now we're back to 6. Do this one more time. That took 4.5 seconds. So notice I was down to 4.2. Now we're up to 4.5. The code's a little simpler. But I mean, the code didn't really get that simpler because of my change. And the performance is unpredictable. So let's leave that in there. Let's recompile that. And we'll find that this performs better. So I think that's the best trade-off I'm going to get, unless I have some big revelation sometime in the middle of the night and it occurs to me, oh my goodness, if I just add one more if statement, everything's going to be magic. Sunshine and rainbows. So that took 5.5. This took 4.5. This took... I think part of what's clogging this up too is that I've got some tests going in the background. Which could be competing for the same resources. So I literally took the same code. What? Okay, that's funny. Like literally the only thing that changed between now when it's taking 5.5 and earlier when it was taking 4.5 was this line of code being the other way around. And so there are two things I could do here. One would be stop the processes I've got running in the background to get a saner test. Two would be just run this test a few more times with the little condition swapped back to the way it was originally. Like I was saying, there's absolutely no way that the compiler could not know to optimize this. And furthermore, we're talking about bitwise operations. We're not even talking about array indexes and stuff. So I would be stunned if the order of that statement had any effect on performance. So that was 3 seconds, 3.5, 3. I mean, yeah, so what I need to do for my own okay, 5.5. There we go. I was going to say, for my own sanity, if this doesn't, like, start returning 5 and such, then it's not a matter of the background process. But no. Like I was saying, the order of that statement doesn't matter. It has no impact on performance. It's the fact that I've got background processes running, which is affecting the actual testing time. So, yeah, we've established that this can take 3 seconds to run. If there is anything about the compiler failing to optimize this really trivial, simple if statement, that's the compiler's fault. That's not my software's fault. So, yeah. Spiffy. Anything else? I think this is good. This looks really good. Okay, get status. So this shows, going back to here, step 1 was merged Fabian's fix. 2 was adding some more tests to this test file. 3 was rewriting the move generator, which I had already done, but had a had a bug in my rewrite of it. I'm not sure how my testing this morning ever tested positive and actually worked, but you know, it works now. That's what matters now, and I don't understand how it was working earlier this morning, but I understand now how it works, so that's a good thing. Um, and yeah, now what I'm gonna do is uh, do this last part, check it in, upload it to GitHub, and understand that this will almost certainly fail the test because his code seems to perform better. But who knows? This is why we do the tests. And possibly with me running Stockfish testing in the background, that might be generating too much noise for my own testing here. Maybe somehow, I don't even know how, maybe this will perform better when it comes to actual test time. We're close enough. We're within the same order of magnitude that this is actually worth doing at this point. Get diff. So unless I've like done something atrociously stupid here, I think we're good. Get rid of that. This last little part here is something that probably should go regardless. I need to separate these 3 lines of code into a separate change. That's funny. No, but I'm going to include that in my branch. Those damn 3 lines of code. Making my task slightly more difficult. Okay, here's how we're going to do it. I'm going to take those 3 lines, cut them out of this, put them into master. Unfortunately, I need to test that on master, but we're doing the same damn thing for anti-chess. Of course it makes sense for losing chess. But yeah, that should be its own change. That's not part of what we're doing here, is the key point. Okay, so let's go there. Prob cut, skip when in check. If we have a good enough capture and a reduced search returns a value much above beta, we can almost safely prune the previous move. Not part of what we're testing right now. Great idea. Probably should be done. Not part of what we're testing. That's going to be a separate change. Incredible as that is. Okay, does this still compile? Does this still run? Probably. Oh man. We're getting close to match time, guys. 1 more hour. Then we'll have the bug house. Okay. Oh, I don't need to wait any longer. That was done compiling. I scrolled down and there were my results. Okay, it still compiles, still runs. We're all happy. So git add star.cpp star.h, git status, git commit, simplify legal move validation. Simplify checking. Simplify legal move check. By remove can, let's say replace with can capture. Okay, get branch dash v, get push origin losers generate moves. Okay, I can submit that for testing whenever I'm ready to submit it. Get checkout master. Check if anybody's somehow merged things into master while I've been away. Probably not. Before we go too far, wait, did I check out master? Yes, I did. Of course I did. So compile master. And once that's done compiling, run the bench. And once the bench is done running, then add this change to the search routine. Rerun the bench. Probably end up with more nodes than previously, but it probably executes faster because we shouldn't be pruning nodes in terms of coming up with good moves. So Stockfish, bench losers. Go bench those losers. 2.2 seconds. Okay. So that's a different order of magnitude than we were talking about earlier. 3.2, whatever, somewhere in that ballpark. Our bench number, nodes searched, is 2332039. Now, what I'm saying is we shouldn't be pruning nodes in that particular circumstance. Make build. Oh man, I'm gonna have to submit this don't prune, losers don't prob cut. This needs its own test. It's the dumbest 3-line change in the world. It needs to be tested. Okay, well, I'll submit the request to test that. 2332039. Oh, hey look, we got the same number of nodes searched here. So that affects such a minority of positions that I don't think it merits the level of scrutiny that it's going to be given, but, people are all gung-ho about this testing stuff. So, git diff. Okay. Get checkout. The losers no prob cut. Get add search.cpp. Get commit. Do not for losers chess, do not prune, do not prob cut prune after a capture. I mean, that's common sense. But you don't want to make any kind of pruning based on capturing for variant where you don't want to capture. But Okay. Git push origin, this new branch. If nothing else, this gives me an opportunity to show off the methodology we use for doing the tests. So this is going to be a different test than what we were discussing earlier this stream. This is us saying we got losers chest, we got a new branch, there's our signature. And this is going to be losers, no prop cut, simple fast test. Add some code, so it does need to go through this kind of particular SPRT test. Where's my commit message? For losers chest, do not prop cut prune after a capture. Submit. Okay, that was added to the queue. We see it right there. Got 23 hours of testing in the queue. This one will take 2.7, it's estimated. It's not going to take the full 2.7. It's going to finish way early because that's such a common sense measure. It's going to perform well. But it needs to be tested. There's no harm in testing it. So, what now? Oh, so I guess I could create the test, right? Get branch-v. The thing I checked out earlier today. Oh, I don't have it anymore. Let's see. What was it called? What was the name of his branch? I think it was like fixed losers or something. I have to actually follow this to get the branch name. Yeah, it was fixed losers. So get pull. Oh, what are my remotes? Get remote v. Get pull in fab. No. Get checkout. Because I've already fetched this. Get push origin, this new branch, fix losers. Oh, in fact, no, it's been merged to master. I don't need that. Get branch, delete, fix losers. Right, so I've re-merged his change. I've merged stuff. So I have a notification from him. If I do, I'm going to hang on. Yeah. Took me a while to figure out what he was getting at there. Before I accept his pull request, wait. Okay, check out. Oh, right. So I verified that the bench number didn't change for this test. Oh, shit. I submitted the wrong bench number, guys. Isn't that great? Oh, man. I meant to do this one. Alright, get checkout master we've already done. Let's compile. So, in my zeal to get that thing submitted, I put in the wrong bench number. I've got to submit the damn test again, and this time put in the correct bench number, which is some number starting in a 5. Okay, we can do this. Stockfish bench is the command. Not Stockfish bench losers, it's Stockfish bench. There's our number. I have done this before too. Man, this tool is, there's just a lot of details you have to keep track of. So we're going to submit a loser's chess. Here's our test signature. It has not changed. I need to verify that before actually submitting the test. So let me actually start on that. Get checkout, or get branch, list my branches. Get checkout this thing. Bench that. It's going to work, but just as a courtesy, we'll do it that way. Fast. Losers, opening book. Message is going to be this for loser's chess. Do not prop cut prune after capture. So here we go. Yep, indeed it did pass, so we got the same number, meaning that it takes the same number of positions looked at to come up with the best move for the set of test positions. All right, so that's that test. Okay. Losers generate moves. This is going to need its own new test, so I'll add a new test. Losers generate moves. Oops. So I need to get check out master. That's not what I'm going for. I'm looking now for this branch. Let's check out that one. Let's recompile before we do this. There's just so many manual steps to this process, and every manual step is error prone. Mostly because I forget to do the steps. So what I need to test here is I'm still going to get that magic 5888 whatever number of number of positions looked at. That's all I care about at this point. To be really thorough, I should check that the number of legal moves from every position is identical. So let me do that. Perf for perf 6. Okay, so here's our number, 442438895. Remember that number. No, I'm kidding. Fishnet Stockfish is going to go there. Oops. Get checkout master. Redo this whole compilation stuff. Oops, that's not, this is the number. This 119060324 is perf 6. So I should get that same number for loser's chess from the initial position. It'd be nice if I could just come up with the number of legal moves from all the test positions too. Just to verify sanity of this approach, but oh, I forgot to set variant to losers before that. Set option UCI variant, except it's not set option UCI variant, it's set option name UCI underscore variant value losers perf 6. Yeah, for whatever reason, the Stockfish team is super opposed to helping us automate these sorts of things. And they say, oh no, the current process is fine. Don't worry about it. Like, guys, you guys are ridiculous. But apparently this is the way to do it. So that's what we're doing. 460-38682. Remember that number. Let's grab this line here. Run fishnet, this one, the one I just compiled. Perf 6. You should get that 460-38682. Shit. That's like not even on the same order of magnitude. I don't get it. Nodes searched greatly increased. Time of the search greatly increased. I think it's because I'm using nodes to go find other nodes. Yeah, well, if I tell them that, they'll be telling me, oh, you're wrong, that the error is between the chair and the keyboard. They will give you that sort of advice from time to time. They're busy folks. I don't mean to disparage them too much, but they're... I don't know what to say. So, yeah, the number of nodes searched differs. So I can't even submit my test. My code performs just about as well as the master branch code, but I'm not actually able to submit the test because these numbers are way off. Well, curiously, wait, I just checked out master, right? Yeah, so master's probably correct. My numbers are almost certainly wrong. So I'm not even in position to submit this for testing. It's not ready. I need to start by figuring out where are the numbers wrong. Perf 2, that's obviously 400. Running on my code, however, loser's chest, perf 2, 400. Okay, that's fine. My code, I typoed, perf 4, 178047. Perf 4. So you see, already on move 4, our node counts differ. Mine is finding all the moves that the master branch is not finding, which is pretty much a bad thing when you think reasonably, intelligibly about it. Perf 3, there's mine, 8571. There's the without my patch, perf 3, this is 8067. And you'll note that for most of these it's all the same, but it's like got to be E3, and when a capture happens next, that that somehow I'm getting extra nodes in there. So yeah, the way I coded it is throwing off the perf numbers. So branch is generating incorrect perf counts of so I am not yet submitting my changes for testing. Not yet ready. Submit my changes to test. Not ready to continue. What do we call this? So my patch is not yet ready. Okay, that's cool. It's a very methodical approach. Probably saved us headache downstream. The test result of this idea. Oh, what? Losers prop cut versus master. Oh, is this the same thing? I'm not the only person to think of this. Okay. Oh, good. Great minds think alike, I suppose. Yeah, this isn't doing well. Like I said, this is such a simple common sense measure, but it doesn't hurt to test it. But it's not passing the testing. Not at all. No, it's winning more than it's losing. But not by a wide enough margin for that to count. Interesting. Well, okay, so that's that. I'm not going to generate my new test at this time. Where was my notification? My notification went somewhere. Losers, no prop cut. Oh, there it is. Let's go to the commits for this branch. Oops. I did not realize you already identified this. You already created such a patch. Yep. He is entirely correct. So I'll go back and delete that at some point. Because it doesn't make any sense. Something's really weird there, but whatever. Prefer captures close to kings and crazy house. So this is a code change, not only where Stockfish is performing better because of the code, but it's performing significantly better. So we merge it. No question there. So we got all these other notifications. Upstream people are doing stuff with Stockfish. You know, I'm not sure. Fabian sets our testing guidelines, and I don't really care to argue with him. I know the official Stockfish team does 0.5, but maybe we're doing 0.10 because the code is just not mature enough for 0.5 to make sense. I don't know. In theory, we could make that 0.8 or 0.4 or 0 anything greater than 0. The official Stockfish team has pretty strict guidelines because they've been doing these kinds of things for quite a while. We just picked 0.10. At least I think Fabian did, because like if we can't make a code change that significantly improves it, is it even worth bothering with? And because, like, this is only testing it for one variant, not for all the variants. So if I make a change for the sake of a single variant, it's probably going to degrade a standard chess performance. But yeah, I'm open to changing that 10 to something else. Yeah, there probably is. There might not be, but we're assuming there is. Mm. So, get branch v. I'm not merging that. So, we got all these other branches. I think, yeah, all these branches are active. It's unfortunate that this Crazy House King safety thing didn't pass testing. Because this seems like such a common sense measure. That if an opponent is holding a queen or if they're holding a rook, you should be much more concerned about your king's safety. At least for a human playing Crazy House or Bug House, queens and rooks tend to be quite devastating compared to other pieces. Yes, other pieces can checkmate, but if you get mated, it's probably because of a queen or a rook. Now, there are some exceptionally talented Bug House and Crazy House players out there that can checkmate with pieces other than that, but I don't know, man. So, it's unfortunate that didn't work. I think what that's saying is that after you place the queen or after you place the rook, that evaluation still has to be pretty good, but I don't know. Not entirely sure what that's about. So I'm not sure what else to do. We still have a lot of things in the testing queue. We've got an entire day's worth of tests, or 23 hours. But earlier today, yeah, in fact, here we are, CTOX. I'm perhaps mispronouncing his name. I don't know him personally, as far as I know. But yeah, he's got two machines, each doing 15 CPUs at a time. So when this says 23 hours, that's 23 CPU hours, which is less than 1 hour on his computers. Fabian's got 7 cores running, apparently. And there's my flagship, running 3 Stockfishes at a time. When they're running 7 and 15 apiece. I'm just chugging along at my own pace, you know. Doing my own thing. Yeah. So it's good that I've got these other people helping me out. I could just submit the... Yeah, one of the things that was kind of holding me back is I don't have some kind of supercomputer that's got all these cores on it. Like, yes, I'm interested in this as a hobby. No, I'm not going to buy a supercomputer just to do some development. I'm going to trust my instincts, and I mean, apparently other people didn't like that, so now we're doing some automated testing. With all these intermediate steps of, oh, thou must make sure that the perf numbers match, and thou must make sure that the bench numbers match, and whatever. I mean, it's helpful stuff. Yeah, this took longer than expected. And you missed the part. You missed the conclusion. The conclusion was, I can't submit the test because the numbers don't match. Like when I say go from the start position here, after e3, after 1.5 moves, or white makes 2 moves, Black has only made one move. I'm getting 544 positions. They're getting 484. Something's not right. Or like knight h3, 395, knight h3, 381. I'm almost certain that Fabian's changes are correct and that mine are somehow messing with the numbers. So I can't even submit this. Woo! We got high winds here. Should I be taking shelter? I hope not. I did eat. That was their other highlight, but didn't depart too long for that to happen. Yeah, we got high winds. We'll go over wherever the wind may take us. Maybe I should check if there's a severe weather advisory. Although there's been worse in the area. 1 second. Man, wouldn't it be a pity if I had to cancel on Chess Whiz to say, we got a severe weather alert. Oh. Okay. Checking messages. My Twitch export of my Go thing from the other day has succeeded. Woo! Alright. Weather advisory. Weather alerts. Come on. Okay, sphere alerts, weather map. Do I have a chainsaw murderer up? Well, not usually. Usually no. Alright, checking this on the phone is ending up being tricky, so we're just going to check it using the computer. Weather advisory, city name here. Wind. Weather warnings and watches. No warnings or advisories in effect at this time. There's something on the radar, but it's not a severe weather advisory. It's snow. We're gonna get snowed in, guys. Alright, whatever. I'm not gonna cancel on Chess Whiz, just due to a little snow. Yeah, no, that's just really high speed winds going outside my window, which I have fastened as securely as possible. Yeah. I don't know if you've ever heard that song, Winter Wind. You have to ask Zug to play it some. Well, I don't know if Zug knows it. But he probably does. He's a professional pianist. He's excellent at what he does. I don't want to say... well, now, I mean, I just look like a jerk if he doesn't know it, but he's quite good at what he does. Even if he doesn't know it, he knows plenty of other pieces, which are quite good. Yeah. It's not often that the wind acts up that badly. It's been worse, but often it's better. Okay. Well, it's half hour till match time. I think I can afford a break from this section of the program. So, for the sake of helping me highlight this later, as well as the fact that the YouTube video editor won't let me break my videos if they're too long, I'm going to temporarily stop the stream and come right back. Alright, so see you momentarily.